Hello, I'm MC Toon, world's worst rapper. Tonight, we've got a special guest. Gleem is joining us. And hold on just a second here. Just in, there we go. Gleem, how you doing? I'm great. Yeah. Um, yeah. So, a lot of time people wonder. They say, "Are you, where's your evidence that you're the world's worst rapper?" And I'm like, that makes sense because I ask for evidence. So I think maybe we'll have some evidence later of my rapping. So they don't hear you. Hold on a second. All right, Gleam, say hello.
Mic check. Hello, hello, hello. Mic check one, 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 one.
There we go.
Good evening to each and everybody.
I see you now, and I hope that they can hear you. So, and I gotta close out my notifications on Facebook make noises. So, my notifications on Facebook make noises. Oh, and now I hear a echo.
Yeah, Chris said it's fixed.
Echo. Is that you echoing? Or
I
no?
don't
Oh,
hear any
that's
echo
me.
at all.
That was me. All right, I had my watch page going. So, all right. Always a little bit of technical stuff. So, Surf says they can hear you now, but he wants it back the other way. So, sorry, Surf. Gleam's here to talk. So that's all good. So, Gleam, do you want to introduce a little bit about your position and maybe a little bit about who you are and stuff in case people don't know?
Okay, yeah. A lot of people are confused by my position because they see me in the side chat a lot. And I'd say attacking the globe. Yeah, let's say it as that. Let's say as per the video put out earlier, I'm a flat Earth sympathizer. I think that's the best way to put it. A flat Earth sympathizer. And the reason why I sympathize is that I truly believe that we're all human beings in as much as we can all talk a good game, yeah, and we can all say that evidence this, evidence that, this proves this proves that. But when you look at the grand scheme of things from a god frame of reference, looking down on everyone, we can't prove anything. We can't prove anything. We can say, yeah, we can look out and see that boat going over a horizon. Globe Earther's going to say, yeah, that's definitely the curve of the Earth. Flat Earther's going to say, no, that's going over an actual band of refraction / distortion, perspective distortion. So I call myself a Mac Earther rather than a Flat Earther or a Globe Earther, where I believe I can't prove either model to you with absolute certainty, with absolute 100% falsified evidence to say to you, it's definitely a globe or it's definitely a flat Earth. So I detach myself from it all, stand back, but try to ask some difficult questions. And as today, I see a lot of rhetoric going on in the baller department, which is basically saying, yeah, we've got a working model. Yeah, where's your working model, flat Earth? And it's completely the opposite. When you look at mainstream science, they're saying, oh no, our model doesn't work. We need to patch this up. We're in serious crisis mode. So I try to put globers in check, but also don't think that I don't put flat earthers in check as well when I see them saying something wrong.
All right, that's fair. And you are now. I'm a programmer. I write software, and you do something similar, huh?
Yeah, sure. I mean, I'm heavily into computers from when I was a kid. Really, I've been through college, done programming, networking, and my actual job as throughout my career is IT manager. But it's been mainly for small companies, so it's not a massive thing. My last major job before the job that I'm in now was for a massive call center. I was the IT manager there, designing CRM software, as well as obviously maintaining all the hardware and setting up all new users, whatnot. So my background is fully IT. My I wouldn't say hobbies. I think the majority of my job is SQL programming, database programming, analyzing data, and I like designing .NET CRMs, basically front-end CRMs, which are mainly web-based. So yeah, I'm a programmer in C#, VB.
All right. Well, I do Java and plenty of SQL and some Python. So
yeah,
good amount of overlap there. All right. So you had a little bit of a rap throwdown that that you put out. Let me see if I can.
I will say this was your suggestion, and me being a rapper, and put it this way, I as a part-time, as well as doing that same job when I was doing the 350 call center. When I was doing that job, I was actually doing part-time of teaching young people how to battle rap. So that was my job, to actually teach young people between 11 and 19-year-olds how to actually write battle raps. However, the one core thing about it, which I hope you noticed, and I hope you noticed, it adheres to your rules of debate, where back in them days, because obviously you're dealing with young people, and we were dealing with deprived young people as well in urban estates and whatnot, and we couldn't have any curse words or swear words. So my philosophy, and still is today, that a swear word or a curse word is a replacement for a word of intellect, let's say, for want of a better phrase. Yeah. So, and I said that exact same phrase to Dell, and I won't tell you what he said. He cut me off and went, F off.
I can hear him saying that. All right, let's see if we can get that. We'll do this rap battle. You'll do yours here, and then I'll do some rap too. So I got it queued up there.
I'm going to mute myself up. The reason why I've recorded it is it's 2 a.m. in the UK here, so I don't really be shouting it out. So let me be quiet and I'll mute up.
All right, I'll play it, and then and he can't hear. I don't have the sound set up to hear it, so I'll let you know, Gleem, when it's done.
MC Tune. Your head's a big empty space like FEAJ's moon. To fit it all on the screen, the rest of the internet had to make room. Our wolf make you quake at your doom and immersively make it worse for you who claims to program games but ain't got a clue about first-person view. Your whole collective will collapse like non-sect did, ever since I petted Irwin's cat for actually getting neglected. Simon Dan's a wet drip, my evidence better than Cheswick's. I live 5 minutes from Tintin and he's definitely a Jesuit. I'll dox myself, I ain't ashamed. I live where Craig was Navy trained. I find it strange I've never seen him and Vicky Pollard in the same place. Sparkane gets sparked and caned for only having half a brain. Heath Carmoody set him straight, now Sly's a lion, laughing shame. I'll slap delete in victory for Baldy Cat's defeat. P.S. Waves at San Diego University. An emotional boatload get dumbed down by number clowns who don't know that LIGO found lightning in a thundercloud. Hundreds like Rumpus who know something and you're all wrong. Maxwell over Fermat, you utter moron. It's getting worse in George's Electric Magoonie verse. Under pressure with the wrong model and didn't do any EU research. You'll get what you deserve. I'm testing your knees jerk, and it seems human beings have pride and dignity to preserve. So fine, get your science from a pilot and ignore me. That guy Bob's ability to lie is a liability for me. I retired Rory, I won't bore you with a story. Basically, he owes me 5G, I think he meant internet surely. So the fact of the matter is, all of you are Looney Tune, and it didn't need a Stanley Kubrick movie flick to prove, or a Martin Luther King effect switching up the rules. You fools recruit more flat earthers than debase 200 proofs.
All right, well, there you go. There is Gleem's epic rap throwdown. And thanks for that. Well, I don't know what you guys thought of that, but as I said, I am the world's worst rapper. So I'm prepared, though. I have something ready. Are you ready, Gleam?
I'll mute up. Yeah.
No, you don't have to mute. It's okay. But
Oh, cool,
so
cool.
I got a little beatbox from here. I do this. Alexa, boots and cats.
I could have done it for you.
There you go. You got that? All right. That's terrible. All right. So here's my rap. This is. Can you see that? That's it's for you, Gleam. Special. Yep. There's my rap. All right. Here. I'll unwrap it for you since you're not here. I'm sitting on a floor that I've
What have I won?
What's that?
What have I won? Look at what you could have won.
I could have. Well, this is so here we go. I installed a floor right that I'm sitting on here in April, and so here it is. There's the epic right there. Gleam is a cotton-headed Ninny Muggins, and then it's citation epic right up there. So where is it? I can't find it. Anyway, there you go. That's for you, Gleam.
Can I make an observation?
Go ahead. Yes.
Isn't cotton cotton, or is that an American English thing?
You know what? I misspelled it. You're right, but you get that for free.
Sorry, that's the English teacher in me.
Good. No, I did misspell it. All right, so there we go. Worst rapper in the world. All right.
Okay.
What we have today is you kind of had responded from yesterday or last week when I had a video, right? I think you were responding to that at least, where I had what's his name, Anthony. That guy was goofy.
Yeah, that guy. Yeah, with the guys in the shed. Or
in the shed, yeah. And I'm
yeah.
like, I totally think Dell is in there with you, but he didn't even know who Dell was. So
they were shed high. They were shed high.
They were. I didn't see them. Maybe I wasn't watching close enough, but they did seem that they had been having some stuff. So,
No, I didn't mean that way. I mean they were more laughers rather than shouters. And in Dell's defence, I will say there is a massive divide between the rest of the world and people living in the UK, where we're all used to Scottish people being like Dell as normal. That's normal volume. Put it that way. That's normal for a Scottish person. Seriously, it's a well-known thing. Similar to Russian. Russian, when they speak as normal, it sounds aggressive, but it isn't. Similar to Japanese. There we go.
German?
That does sound abrasive, or it can do.
Yeah, but I saw Rammstein, and they did like a ballad, and it sounded like they were going to kill you.
But that's it. A lot of it is dialect rather than him actually getting angry. It's just Scottish people. You could say all Scottish people are angry, and you get that anyway from The Simpsons, don't you? All over there. With Willie the Groundsman pretending to be angry, but he ain't.
I had a nice conversation with Ali B. He's Scottish, right?
Ali B is cool. Yeah, Ali B is cool. Cool character.
He didn't sound mean. All right, so I'll pull up here.
Yeah. So back to that video.
This is what I showed to him. This was I put the observer on the equator on the day of the equinox. There's 2 of them in a year, and then he agreed that this was a good prediction, that it'd be 45 degrees northwest.
Yes, I agree as well.
Okay, and I'm like, yeah, but here's the observation is due east. So
yeah,
and he didn't have anything.
I have something for this. Put it this way: if I was to say to you, here's a photograph from Earth with a flat horizon, with no measurable curvature going from left to right, which you wouldn't expect anyway. If I was to show you that and then zoom out of Google Earth and see the big sphere Earth of Google Earth and say to you, look, there's loads of curve there. You're not seeing it in the photograph. You would obviously say, that's a scale thing, isn't it? That's a scale thing, of course. Now, what you're doing here is exactly the same thing. you're taking what's known, or what I call, as a God frame of reference. So you're not actually looking and looking from how the observer sees it. Okay. Yep. So is that not a fair point? Now, I will say that is an inspiration to my line bit about you don't know how first person view works, because this is not first person view. This is a God game. Yeah.
Sure.
If you get that.
Yeah.
Yep. So you're playing a God game, but then trying to explain what the observer sees, because the observer is the one recording the 90. Is it 90 to 207? 270. Yep.
Yeah.
That's it. 90 to 270 across. So it's the observer that is recording that. So you should be obviously looking from the observer's point of view, rather than the God frame of reference. And in the same way, you would call me stupid for saying, "Don't be silly, Gleem. You wouldn't expect to see that big Google Earth curvature when we zoom in onto the very finite small space of Earth." So I can take you through it step by step, and that's what that PowerPoint that I've just sent you is. It's just basically 5 steps, and hopefully if we try not to drag out any of the points and get caught up, because what I'm most certainly not here to do today is to prove the flat Earth model. Okay, all I'm looking to do here is to basically say that you cannot disprove the flat Earth model with your current set of thinking. Do you understand that? In as much as I don't care if you disprove the flat Earth, which in my own personal view, I don't think you can. As in, I don't think anyone can disprove the globe or the flat, because we're just small individual beings on this very, very large surface. Okay. So, yeah.
So what is missing from this then, that you think?
Perspective.
All right. Things
I
we
know
can
that
calculate.
sounds...
We can calculate perspective, right?
Of course. And I haven't done the full calculations here, but I can give you the concept in order so you can calculate it. And I can give you the basic numbers of what I've used.
Okay.
Yeah.
So
if you want to present the PowerPoint, yeah.
Yeah, and I'll send it so that you can see it as well. Let's see. So you can see your own PowerPoint. Where'd it go?
I can see it on the main stream, but not on the Hangout.
Yeah.
It's okay. I can go from the main stream. It's not a quick or fast or anything. So the 2 main points I said to you is I want to discuss perspective and gravity, because in my eyes, forget the pun, those are the 2 core aspects, which are the 2 main things which differentiate the flat Earth from the globe Earth. They're the two model key points which are different. Obviously, perspective is curvature, gravity is density and buoyancy, let's say. So it's okay. 2 different concepts to explain the same thing of what you're seeing or experiencing. So if you go on to the next slide.
Okay.
It just gives you the contents page, which will give you I think it was 5 that are put in there, and the very final one gives you the main conceptual basis of exactly how this works. Just to get this straight, I'm saying that when you're looking down from a God frame of reference, there is definitely 100% a geometric 45-degree circular arc from sunrise to zenith, noon, basically. Can I just confirm that we are correct in understanding what you was explaining that problem? Because he basically he did not really have an answer for it, did he?
No, he didn't.
He just said no. He just said, yeah, well, that's right, but the map's wrong. And then you pointed out it's the same map as on his T-shirt. Blah 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 blah. Yeah. So either way, have I got the correct notion of exactly what you're not understanding on how that 45-degree arc of the turn of the circle is not what we actually record, because on I've done the calculations basically previously on Wolfie's Equinox challenge, which was on the equinox, obviously, but on the equator in that quintessito sundial. So
Oh yeah, the one on
Quitsato or something like that,
yeah,
I think it's called
Quetzalto
Quitsato. Yeah,
in
yeah, and it's
Ecuador.
just slightly on the equator, just perfectly there, and they use it, and it's obviously the shadow of the gnome. It goes straight over, so it goes from
Yeah.
east to west directly, and there is a minor deviation recorded by NASA and whatnot on the actual sun's path, which is 0.3 degree, I think it is, but that's unmeasurable on such a scale of that sundial. But either way, have I got the problem correct?
I
That is
think
the
so,
problem.
yeah.
Yeah, yeah. Okay, so cool. If we go on to the next slide, then. Um, I hope you understand this, and I've accused you of not understanding this in that battle rap of saying you don't understand first-person view, but I hope you do understand there is a difference between perspective view and orthographic view. Is that correct? You
Yeah.
understand that? Yeah,
Yeah, orthographic is horizontal, and it doesn't show things as you see them, but you can, when they're drawn to scale, you can measure to see what types of like an angle would be, for example.
exactly. It's a geometric view, not a perspective distorted view. So everything will remain the same size no matter how far it is away from each other. Whereas in a perspective view, obviously with distance, the angular size makes it get smaller, and it makes things such as you can hide a massive 800,000 mile sun behind a 1 inch thumb
Yep.
because of that perspective distance. Yeah. But with an orthographic view, you would always see that thumb as 1 inch and the sun as 800,000 miles and the thumb as 1 inch. Yeah. So that is the difference. The difference is distance and perspective reduction. Okay.
Okay.
Yep. So have we flicked onto the next
I can go to
slide?
slide 3. Yep. It's got the
Yeah.
perspective
Okay.
view, orthographic view.
That's it. So, although my citation here is from the University of Illinois' molecular department, I'm sure you'll agree across most sciences. If you've got one concept for one, it runs across the same, virtually the same across all. And I think you'll get this with the two things here. If I can just read that out, um, just for those who cannot see it, who have got low quality on there. It says it's basically describing the difference between perspective and orthographic views. And in the perspective view, the default, objects which are far away are smaller than those nearby. In the orthographic view, all objects appear at the same scale. Since some prefer one over the other, both options are available. Perspective viewpoints give more information about depth and are often easier to view because you use perspective views in real life. Orthographic viewpoints make it much easier to compare two parts of the molecule, as there is no question about how the viewpoint may affect the perception of distance. Okay. So I think the core point that I'm trying to put across here is a lot of flat earthers complain that globe earthers automatically put any analysis into this side view of orthographic, which completely removes all aspect of perspective and depth. And it's that last sentence says there's no question about how the viewpoint may affect the perception of distance. Okay, so if you want to remove that, then take it into an orthographic view. And flat earthers' core complaint is that you're doing that on purpose because that is the mechanism for them to hide stuff, their perspective to hide stuff. Okay. So if you
That
look on the
that
right,
who's hiding stuff
yeah,
with perspective?
flat earthers.
Okay.
Yeah. Well, they say that obviously the flora appears to meet the sky. and this apparent point is a dynamic point of your perspective, where everything beyond this point then starts getting blocked by bottom up. Okay, and also you've obviously got the ether band, which we'll get to in a second. But from a geometric point of view, if you look at the two different views there, the orthographic view on the left-hand side, that is showing the objects as they are and as they will always be. So no matter how far that red block gets moved away, it will always stay that same size. Now, in the perspective view, obviously the floor appears to rise and the horizon is halfway through the picture. And the red block has shrunk with distance. So it's actually a 2 meter block, the red block, and the green one is a 1 meter block. So in the perspective view, you can, and under all ideal conditions, you can say that you can make it look or appear as if that red block is identically the same size as the green block and stacked on top of each other from a particular angle of view. Would you agree with that?
Yeah, you can't in a simple sense, you can't identify, if you can't identify distance or somehow measure size, then you don't know.
That's it. If there's no depth perception
we've seen the room where you have a person on one side, a person on the other side, and right, and then they and one's tall, one's short, and then they trade sides, and they switch who's tall and who's short, and it's because the room is skewed.
Yeah, the room is skewed. Yeah, I've seen that. Is that in Florida? That's the one in Florida.
Oh, I don't. I've just seen the video. I don't know where it's actually at.
Yeah, I think it's in Universal Drive, whatever it is, down the normal Kissimmee route.
Okay.
But yeah. Either way. So, do you agree that there is a difference, number one, between the orthographic view and the perspective view? That's clear. I think that's a common understanding.
Yep.
Do you agree with that? Yep. And then this now gets where things block things on the next slide. Taking into account there, even though half of the block is actually blocked, this is the weird thing about it. On the left hand side, on the orthographic view, obviously half of the red block is blocked by the green block, whereas in the perspective view it actually reveals all itself because you're peering over it. Okay, and this is mainly one thing that globe earthers say: it cannot be a flat earth and the wave height cannot be blocking anything, because if we're 2 meters tall, 1.8288, whatever it is for 6 foot, if we're 2 meters tall, we can see over that 1 meter. Now, I will say in this circumstance, yes, I will agree with that. Okay, so there is a certain point where you'll be able to see completely over the object. However, if you separate it with distance, there will come a point, as you'll show in the next slide, if you can put it onto the next slide.
There you go.
Oh, is that the right one? No, I think you skipped one. There's a next one called two obstructions.
That's the one.
Sorry. I think I saw the guy's face thing. So then you've got two obstructions here. Okay, so you've got a 1 meter block, a 1.5 meter block, and a 2 meter block. Orthographic view, now that you understand that there is a difference, we shouldn't be looking at the orthographic view.
So the orthographic view that you have on the top left there is, did you do that, or was that from the University of Illinois?
Oh, I apologize. I did actually put a little caveat underneath my last one saying I have designed all of these diagrams. It was only the text, from that University of Illinois. This is just my conceptual.
Okay, because I've never seen the orthographic view straight on like that. I have only seen it side on.
Yes. No, that is exactly it. The orthographic view is what I'm showing at the bottom, basically.
Yeah,
you understand that?
So that's why I was a little confused.
Yeah.
Why are we seeing the orthographic view from the head on?
That
from the
should
observer,
not.
The observer never sees that.
Yeah, it's an invalid. It's exactly that. It's an invalid view, because what I've done there is I've taken the perspective view of what an orthographic would note down and see, basically destroying all perspective. Okay, so it's trying to hit home, which I don't need to, because you've already confirmed that you understand 100% there is a complete difference between the perspective and the orthographic view. So if you dash that away, that is useless and of no use to this conversation now that you understand the difference. But where blockage comes into it is, albeit obviously we know that anything at eye height will never go above eye height. It will always stay at eye height, and the bottom will shrink upwards towards it with the apparent rising floor. If you can see there in the perspective view, the adding the yellow cube in there means that the bottom of or the majority of the red object is completely hidden. Okay. And this is just again on a flat plane. Now, you can say, Lee, where is this ever shown in anywhere? And I would say straight away over water. Any observation over water, if you can imagine, object A is a small wave that's nearby your feet or nearer to you. And then you've got object B, which are the larger waves. You get significant waves up to, I don't know, you can get them up to 8-9 meters in the middle of the sea. But let's just talk 1 or 2 meters in the middle. And then you have, let's say, a lighthouse on the other side. And what you're actually getting is the swell, let's say, or the wave of the sea blocking it, or blocking a boat going away from it. And then globe earthers are automatically saying that is curvature. Whereas flat earthers,
because of a wave.
Well, it's because of blockage. Anything blocking something from the bottom up. That is exactly what they would say is earth curve. Look, there's curve. Anything blocking that.
But what on water other than waves would be obstructing it?
It would be the waves.
Okay, so just
then,
waves.
And then
but waves are ephemeral, right? They're not, they don't freeze.
Not at all. They're dynamic.
Yeah.
So yeah, they're constantly, but it's up and down. You've obviously got half the wave height because you've got the dip. But if you can picture that is a boat moving away, object C is a boat moving away, from a perspective view, that will keep on getting smaller and smaller and smaller. And therefore, if object B is not static, it doesn't have to be static, but on a mean average height of, let's say, 1.5 meters, then it's going to block the bottom of that boat moving away. And that is what flat earthers are saying is the curve of the earth. You're going over that curve of the earth.
So I've a couple times seen people talk like waves, but in general they have other things that they bring in.
Well, the apparent rising floor. The apparent rising floor is one.
No, like the refraction and mirages and all these things is the what I think is the common one. They also talk about your angular resolution, and they talk about vanishing point or a vanishing line, which kind of, I think that's, I don't know if they're confused or if they're intentionally deceptive, because nothing vanishes in a vanishing point for real. It's an artistic thing. They vanish. You don't draw it anymore, or in a computer you don't render it. But in reality, the light still gets to your eyes. You just can't resolve differences within that area unless you can increase your resolution.
Yeah, that's it. And it's a common misconception. I mean, Walter Bisling does do an okay job, let's say, in representing it in the flat Earth dome model. But essentially,
in
what it
that
would
dome
be,
where he has all the bendy light.
Yeah, exactly that. And the bendy light, the concept that I'm going to tell you about now will be the same concept which is required. And if you zoom right in, Walter's model is really good because you can actually flip it around and zoom right into specific bits.
Yeah.
And if you do this, I've done this exact same thing, what you're asking now. He's got it up on there, and it shows exactly what I'm just about to tell you now.
Okay. All right.
And
Well,
yeah,
we kind of got off on other
yeah.
stuff. So you're suggesting that object B in this, I'll bring it back here. Object B in this example is waves that are constantly moving and obstructing the bottom of a. But what about calm days? Because there's plenty of observations on calm days.
Yeah, definitely. But there'll always be a wave height, and there'll always be a distance. Put it this way: it's an obstruction closer to you. If you ever look, you know, when Ranty and all of these are zooming in on the horizon, you'll see this mirage, which exactly that. All I'm talking about here is geometric. So the mirage things is actually the next slide. But on mirages wise, if you notice the waves that you're actually looking at, they're more finer detail, and some of them go up and it looks like they disappear and stuff like that. But the actual waves that you're looking at are nowhere near any of the ships that we're actually looking at in the background. Those waves there are in the foreground, much closer to you.
Oh,
And
yeah,
that's
that's for sure. It would be if on a curve, it would be at the peak of the curve would be the easiest place
apex.
to see them.
Yes,
The apex.
exactly
Yeah.
that.
So
It's
if
much
they're
the same.
Yeah, and if they're not near the peak, then only the taller ones either are, close or far.
Yeah. Yep. And that's it. And from the plain truth's point of view, shout out to Travis there. He shows it where he can show a building where one day he'll be there, and not the tide would have risen, but more would have been blocked of the building from the same position.
Okay,
And
so
multiple people, Ranty's shown this as well,
yeah, so
where
now
an island
the thing
disappears.
about all this is all these things we can calculate because we have the angular size formula, right? So if we know that a wave is
Yep,
10 feet tall, and
exactly that.
and it's 3 miles away, and there's a boat that's 50 feet tall, and it's 6 miles away, right? So twice as far.
Yep.
We can know how much it can be obstructed, and we can use the nice thing about the orthographic view is we can, if it's drawn to scale, we can see how much would be missing, and we could put a protractor on the drawing to see if it's to scale how much would be blocked.
Exactly. And this is what quizzes me. I'm going to ask you a very honest question here.
Okay.
When was the last time that you ever see a globe earther? Because I've probably seen about 6 or 7 take it into this side view, orthographic view, likes of Rumpus, Conspiracy Cats, Miles Davis, all have taken it into this side view, but have never once accounted for any single wave height when they're doing and analyzing over water. Have you ever seen any globe earther account for any wave height ever?
I have on the tfes.org forums.
Okay, I'm not on there. So.
Yeah, Bobby Shafto
Okay.
has done that kind of stuff, and there's another
Right.
another guy.
But
I'm forgetting his name, but has gone over those types of things.
Yeah, I've personally never seen it. Perhaps I've not looked hard enough. That I'll take that on the chin. But the core thing that I'm trying to get at is that I done this on Wolfie's latest video about Bathurst Lighthouse,
Okay.
and you can actually pull up using real world data. This is not me just flinging out, because what I don't like to do, I know what position I'm in where I go out and I attack a globe earther, and I'll blatantly say that I attack a globe earther for not doing his analysis correctly. Okay, and I'm a data analyst by trade, and I'm anal at pointing out things that should have been considered, but in Wolfie's particular one, there is he gives you all the distances, he gives you all the heights, and there is a 3 meter wave height in between the two, which I blatantly asked him, I said, look, I've done rough calculations here, not anything proper, sit down and do it, but I can actually hide using this angular size method by a 3 meter wave, divide that by 2, 1.5 meter wave can block up to 30 meters, I think it was, of the actual lighthouse, which was just under half. I think it was 100 meters or something.
Okay.
So he hasn't considered any of that, although it didn't perfectly match what was needed to be accounted for with the curvature of Earth. There's no account for it.
Sure.
And that's
what
I
now,
don't.
a lot of the time, people are viewing things from the shore, but if they're viewing things from a little more elevation, then in your example here, object A would be below what you can see, right? So if you're 20 feet high and the lighthouse, right, when you're looking at it, the swell in the middle could not be high enough to reach that bottom line of observation.
I understand what you're saying, but elevation, you would have to be up massively for the scale of what I've drawn there is nowhere near any scale of what I could fit on your screen, and you'd be able to see the guy.
Well, all right. So
on
let's
just
say,
a 3 mile distance.
Let's say the observer is 20 feet high, right?
Yeah.
And the lighthouse is 6 miles away, and then object A is in the middle, and it's a 5-foot wave, which is a wave that you can see.
I would say you would see over that. Yeah,
you'd
say
easily see over that, right? So a 10-foot wave, you'd easily see over a 10-foot wave as well. Now a 10-foot wave is a pretty good sized wave.
Definitely.
Right? That people are surfing if there's a 10-foot wave. So
Now let me do something which will now let me turn that lighthouse into a ship. And the reason why I say a ship is because you'll more be able to imagine this because it's in the water. Okay, now put a 10-foot wave there, and an extreme version would be, everyone must have seen the movie, what was it called, the deep one with the sea, where they're in a big massive the perfect storm. That's it, where they're in the ship and they're going up and down and up, these big massive waves. Yeah, so that's an extreme version of what I'm talking about. Now,
the observer was very close to the wave.
Yes. No. Now consider that the red block is a ship, and that is actually in the bottom part of this wave as you take the photo. So a massive, let's say, 10-foot wave, did you say?
Yeah.
Okay. Yeah. So let's say that's 5 foot above sea level, mean sea level. Let's say the ship at that time when you took that photo, the ship was below sea level because it was in the dip of the wave, like on a normal wave, peak and trough.
Yeah.
So
right. I hope this gets back to the lighthouse.
Yeah, well, either way, this is a similar thing, because if you put the wave, all I'm saying is put the wave nearer to the object, and the wave is still 10 foot to the object. Okay,
but when it's close to the object, the angular size of that wave is very close. You know that they're close, right? So you'd see a 10-foot wave because it would actually splash over the bottom of the lighthouse.
Yep, the actual, what I've just shown here, even though you said when I get height, I'll be looking over all of these. What I've just shown here is exactly how that wouldn't happen, because you've got object A in the middle, and at the point, if you're forgetting object B, you are looking over that. So you have got the height there. But then if you have something even taller, nearer, then you need even more height then to get over that object. And then nearer the object is to object B object C.
The bigger that wave needs to be.
Yeah, or the taller you need to be able to see over that, because the angle gets smaller and smaller and smaller, and it gets more. You would need more and more height to get that angle of view to be able to see over it, or for have nothing to block it, to block the bottom bit of it.
All right. So if the viewer is 20 feet high and the base of the lighthouse is 20 feet high on a hill,
Yeah,
right? At no point is a 10-foot wave going to get in the way, right?
you're right.
Okay.
Yeah, you're right.
So
You're right.
So what would then obstruct the bottom of that lighthouse?
Now that would be distance with your limit of your eye. Okay, that would get into, you would need more distance than the 3.25 miles.
Yeah, and it
and then
is.
that and then that gets into your eye level. This is the basic geometry of the perspective versus orthographic. If I can slip through the optical distortions that, again, people don't account for, and then the topology, which people don't account for, again, which is this wave height, and then we'll finally get onto the actual sun part, which I will give you a formula which will allow you to calculate based on your height versus, I'm sure I've given you before, based on your height versus the angular resolution limit of the device, of how much of the floor you'll be able to see.
Okay. So
Okay,
can we
so
break from that for just a second, because Earth is seriously flat, also known as Puss in Boots, has sent a couple messages. Do you know him, Gleem?
I do. Yeah,
Yeah.
yeah.
I
In the
like him.
chats always.
He's a lot of fun. So he says the globe zombie animal mind is dying. Smiley face FE heart U. And then he said MC Toon is actually a closet flat earther. And then a smiley face with hearts for eyes. So great. Then he said it's a horizontal horizon, not a curvizon. Heart FE, which of course my response is it's a hemisphere. Anyway, and then attacking globe zombies with globe doctrine questions is his final message there. So thank you, Puss in Boots. Gracias.
Muchas gracias. Classic.
Love you, man.
Classic, yeah. So either way, what I'm more putting across is, if you want to do a proper job and debunk flat Earth, okay, do it on their grounds. Because at the moment, all I'm seeing is just a lot of people omitting all of this, which they're saying is the actual, like the plain truth and the ether band. These are valid things. These are not just made up imaginary things. You can see them, you can calculate them, and you can work it out. And this is the thing. A lot of globe earthers, a lot of standard globe earthers, let's say, just go, right, that is curve. How far is that away? Go straight to Metabunk, do the curve calculator. Yeah, that looks right. Cool. Yeah, there's a little bit of refraction. We can handle that. And that's it. It's definitely Earth curve that's hiding it. Whereas obviously there's mathematics for the other direction as well, which you dismiss.
Well, let's see that then. So are we on to the next slide then?
Yep, this is just more. It's building up more things of what perspective view and what's omitted from the investigation by the globe Earth side. If they wanted to do a proper job, they'd include all of this. But as you say, you have actually seen other people do it. I haven't really. I haven't, and I think I've been watching quite a few vids.
Bobby Shafto is you won't find anybody.
I recognize the name.
Yeah, he has a YouTube channel, but he crosses his T's and dots his I's very well. He has a warehouse of dots and tittles and crosses, so he's very, very thorough in his observations. So all right, let's go back to
sure. So the next slide.
5? Okay.
Yeah, that's it. If we go to the next slide, that is just basically more elements which should be calculated and should be removed from the view. So what I'm trying to get at here is that there should be a formulation that globe earthers and flat earthers alike should have a set of transforms, or at least some that you can pick out that you know are going to be definite, a set of transforms that transform the perspective view to a geometric view. Because just basically going, right, get that photograph that we've just taken, which suffers from perspective distortions, and just put it in a geometric orthographic view, removing all of those distortions, is not debunking the flat earthers in the flat earthers terms. To actually do it under their terms, you need to actually work out these transforms and then say, look, now we've transformed it and it still doesn't work, it's a globe, or however it turns out, I don't care. But you've got lens distortion. Now, that there, do you see the slight bend and curve on that ticket that he's got there?
On
It's
that
a flat
looks like
ticket.
a check, yeah.
Yeah, on the left hand side on the check. Yeah, it's a check, isn't it? Now, that is the flat earthers camera choice. That is a P900. So that alone, even though it's a close-up shot, obviously you can imagine if you're zooming in using a lot of the zoom and taking the most furthest distance and concentrating on the most smallest, tiniest angles, and you have distortion like that. And it's not massive, it's not major, it's not enough to say, yeah, that is, well, in some cases, I'm sure globe earthers have gone, that is the curve of the earth, when it could be barrel distortion, lens distortion. And then this is another one which is completely neglected by everyone, I think, both sides, which is distance distortion. Now, I'm saying that, and I'm actually lying to death, because it is actually used with by globe earthers to explain why continents take up half the globe
Yeah,
in the
different
blue
pictures of the
marble.
Earth are taken with different focal lengths
Yeah,
from different
and I
distances.
agree with that. That's a
Yeah.
good explanation. That's a perfect explanation for what it is. Only if it's a camera picture, because digital sensors, or sorry, remote sensors operate in a different way, as I understand it. It's not a lens based. It's actually just a radio signal based. But anyway, without getting too far into it, obviously, if you see those three pictures there, it's to basically show that with distance you get compression around the side of the face. Now, I'm going to do a shot from the hip here and just say that that can easily be the reason why you see a globe from space. Okay, the same thing that you use to say, yeah, the whole of North America takes up 50% of the globe. It's because of your zoom and your distance from it. So if it's creating more compression around the edges can also be, let's say, from flat to look spherical, if you understand that.
I do, but it wouldn't make things go away, right? If it are you saying
No,
that pictures
no,
from
that's a
space
background.
are pictures of the flat Earth, and that camera distortion is making things disappear? Like,
Can
if
be.
you're looking at
Can
North
be.
America, you don't see Africa because of
Yes,
the zoom.
because it's, well, put it this way: if you understand how a lens works, then yes,
All
yeah.
right, I
If
do understand how
it's
lens works, and I'm not going with that one.
well, is that not exactly the same thing as what you're saying? Is
Well,
the reason why
no,
the land
because
is taking up more of the sphere?
no. If it's flat, right? If you can see the whole thing, right? So look at this guy, right? We can see his chin, and you know, if you're far enough away to not just crop his chin, you still see his chin, no matter what the focal length is.
Sure, sure. But look at his face. In real life, take away the camera. In real life, is he a skinny guy or is he a chubby, flat face guy?
You don't know, yeah. But
I
there,
mean, personally, I'd say it's more like the middle one,
it's
because it
probably the
was,
middle.
if you look at the millimeter, It's 200 millimeters on one and 50 millimeters on the other, and I think that 50 mil is one of the closest to the human eye.
Yeah, the 50 mil is about what we see.
Yeah. So, but I'm saying we can make something look flat and make something look spherical, more skinnier, more slender. Because if you look at the edges, that's what I'm more worried about. Not worried about his nose, because his nose grows as well,
Yeah.
or appears to grow. His nostrils appear to grow. Okay, so that would be the continents appearing to grow. And then with that, obviously the compression around the side of his face, the edge of his face, is making it look like it's sticking out more to me. Do you get that?
I
So
do, but for pictures from space of a flat, if it's pictures of space, I mean, I just want to make sure I understand. Are you suggesting that pictures from space are pictures of the flat Earth, and because of the camera lens, we're not seeing all of it?
possible.
Possible.
Obviously,
Yes,
there are
and I'm not.
there are
I'm
other.
just not.
I don't
seeing
want to
it.
get into the old. I said this to you as well. I don't want to get into the old. That's a fake picture. That's not a fake picture. Because you can easily come back to me straight away and say, right, we've got pictures from the moon, showing the actual globe Earth, and then stars around it. Whereas what I'm more saying is that when you look back from that distance to Earth, your camera and your eyes are looking into a central point and everything's zooming into that point. Now, with more distance, you are going to get more compression around the edges. So, yes, essentially, that is what I'm saying. Is the Earth has an atmosphere that has something to do with it. However, your eyes are a lens and are curved, and they accept light in a particular manner. And the more distance you get away from each other, I think an empirical experiment would be is if you've got two perfectly half circle flat bowls and put them over two people's faces facing each other, and they walked away from each other, a similar thing would happen where their face would start to fill the bowl, and it would make their face look more like a sphere.
Yeah, but it wouldn't. If it's flat, it wouldn't make stuff not be visible.
Put it this way: if you had a square, if you put a square, drew a square in big black marker, and then if you put a dome over it, a glass dome over it, and then look down straight on it, that square would skew, wouldn't it? You wouldn't get a perfect square. You would actually get a bowed out square. Do you understand that? So it would go towards the more circular route.
Yeah, but regardless of that, which I don't agree with, but say it did, like the guy's glasses are generally flat, right? So you see his glasses.
Mm-hmm.
There aren't the edges of his glasses don't get gone, right? They don't go away because of that.
No, they don't go away. They get compressed. That's the point. It's getting compressed. It's the edges of his face.
Compressed into being gone. So yeah, I don't.
No, it's with distance. It's with distance. So if you can say I think the top one is actually nearest, most zoom and nearest, and then the bottom one,
top one is the farthest away.
Farthest away and most zoom.
The 200 millimeter zoom, yeah, you'd be real far away, and you could tell I've done photography. You can tell the background is blurred.
Yeah, it moves back and forth. It appears to move back and forth.
The depth of field is also in a when you zoom in like
that is exactly what I'm more
blurred.
Talking about.
So, but when you're pictures from space, that they're not, that it acts more like a pinhole camera, where everything is in focus.
Yeah, well, put it this way, then how do you explain the different continents taking up half the size. You have got to tell me that no,
it's your
other
proximity. Yeah, it's your
extra
proximity.
percent is compressed into the edges of the
No,
Earth.
no,
Is
it's
it not?
It's not compression. So this guy, say his ears, right? His ears are around the corner of his face there, right? If you're far back, actually, I don't know if his hood is up the same in all three pictures. Maybe it is.
I think it is.
I don't know.
And
Let's
and
just say
that's it.
his
And
ears. If you get
more
real
around
close,
it.
if you get real close, right, and you take that 16 millimeter and
Yeah,
get
you're going
even
to lose
closer,
some of the back end.
you get
Yeah.
closer, right? You won't see the ears because the cheeks will obscure the ears.
Yeah,
That's
yeah.
what
If you
it
get
gets
right
in,
up
it
to his nose,
physically
then you
gets in the
won't be able
way.
to see any of the hood because his cheeks will be hiding them. No, that's what I'm saying. And the further away he's getting,
Yeah, but the
the
reason
more
why that
you'll.
happens is because his face isn't flat, and it's curved, and the actual, like, his cheeks would actually get in the way and obscure it, right?
Yeah, sure.
So
Sure, and
all right,
either way,
the,
either way, let's not get stuck on it because I couldn't give you maths for it.
yeah,
But I'm just
and
saying
this is all.
it's a mechanism that I see that at the end of the day, it's creating a distortion which nobody accounts for.
I think you can account for it, but the thing is, so we still haven't gotten to the point of what we're trying here. The explanation that we need on is, and just to say, so Bob the science guy is saying that he can show. Yeah, I get it, but the topic is, that we want to see that the 45 degrees.
Sure. Well,
So
let me
review
let me just
for people just briefly here if I
Yeah.
can.
Well, let me skip through completely. Just on the next one, it's just a reiteration of just three
Okay,
things that are normally
okay.
forgotten, and then it's the next
Okay, so
number 7.
I just want to review. So all right, so yeah, Jason McCormick. I like him. Let him, unless he's getting insulting or something. Let him stay. So all right, here's the review. The flat Earth AE map, or any map with the sun circling the North Pole.
Yeah.
We have a 45 degree and a 315 degree prediction for sunrise and sunset. But the observation is due east and due west at 90 degrees and 270 degrees.
Sure. Yeah.
So that was the topic here, and so we're an hour in. We haven't gotten to that point yet.
Yeah.
So,
No, the reason is
Bob,
that I needed you to
we're
understand
gonna move
that.
forward on, yeah.
Yeah, I needed you to understand the perspective thing. If you just want to skip through the next one, and then go straight into number 7, and that's straight into the meat and bones.
Okay, the sun's circular path. Now, all right, I read up on this, so let me pop over to, it's not on the screen. There it is. All right, better be good.
Okay, so on the left-hand side, we obviously have, it's a grid that I've basically made. It's an arbitrary grid. It's done mainly on pixels, where it's 10 pixels per grid. And obviously, each circle is your reducing cone of view, let's say. Do we all agree that that is a standard grid of how your perspective works? Or do you agree? I don't know why I'm saying we all.
We all.
Me and you. And I've got a couple of personalities here that agree. Yeah.
Yeah.
So that is reducing. So
each of those concentric circles would represent the same physical size thing, shrinking in angular size with distance.
Exactly.
Okay.
Exactly that. Yeah. Yeah. So something, let's say your whole field of view there is 2 meters wide. That'll be 2 meters, 2 meters, 2 meters, 2 meters. Okay. So on your right-hand side at the top part, The top part is try and forget about the bottom two diagrams. They're just as confirmation, but the top part is the important part. That each of these segments going down, and you can't obviously do this. I've done this in text, and what they're actually supposed to do is reduce in line size. So as it gets further away, obviously you're covering more distance. Now, with this, the actual sun coming into your field of view, you would normally say on an orthographic view that it should be coming in on the left-hand side, completely far left on the left-hand diagram with the targets.
Yep.
Yep. Whereas what we actually record it is directly in the middle. Yeah. So if you can see with the reducing field of view on the top, now go back over to the right-hand side where it says directly east. It's actually coming in from northeast. Now, halfway down, you can see your field of view is only covering halfway, which would be the next circle, basically.
Well, but your field of view expands.
Yes, and that's
So you
bringing
can
in
see
other
a
parts.
physically wider area in your field of view as it's farther away.
Yes, only of the land, and of the sky, but it will still reduce to that singular point of where you're looking.
Okay, so what if you turn your gaze to the left?
It will still appear to come from this direction because of the scale of the things. So the circle that you're seeing coming in over your head and over to the sunset on the other side will appear to just go straight up in a line. And the reason being is that your reduction in your field of view is countering the arc of the circle. Does that sentence make sense? Because
No.
Okay, so if you look on the right hand side on the top part where it says north and south,
Yep.
if something come from northeast, it would be halfway between the top line, yeah, or let's say even right the way over where minus 62 is on the very top line, yeah. Okay, so directly northeast on the second line is obviously that minus 62, and you follow it right the way down towards the horizon, and at the point where it's getting to the horizon, minus 62 east and plus 62 all converge.
I disagree with that.
Okay, so as it's coming out,
but if you look, if instead of looking east you look north, would the same thing happen where the sun would move with you, and when you're looking due north, would the sun now look like it's coming from due north?
No, because
that's what this is suggesting to me.
No, it's not a perspective thing of your eye. It's more a topology thing with your perspective. It's called a curvilinear path perspective. And you get to see this in Formula One racing, if you ever watch that, where something will appear to be coming around a big, massive curve, and it will appear to kind of slow down. And it's not actually slowing down. They're going just as fast, if not speeding up. It's just because they're going round in an arc.
Well,
it
sure,
looks more straight.
But it does look like it's coming from the side. If it doesn't look like it's coming straight at you the entire time.
Yeah, but that's because you haven't got as much distance as you have here. The distance we're talking here between you and that sun at sunrise is we're talking around about 8 to 9,000 miles.
Yeah, and it absolutely depends on your location, because if you know different locations have different on the AE style maps, different locations have massively different distances to the sunrise, yet the observations
once you account for this difference, the actual degree difference is so minor, it's the same as what is recorded.
Okay. So I don't know. You haven't yet explained why, if it's rising at, basically 45 degrees, northeast, why it appears east.
That my explanation
versus
was that
why
exact
doesn't
sentence.
why doesn't it appear north?
And that's exactly my exact same sentence of what I've just said, because your perspective converges, and that counters the arc of the circle.
But if I turn my face due north, now my perspective converges due north, not due east.
But
shouldn't it bring the sun with it then?
No. Why should it change the sun's path? The sun is rising from the same arc.
It's physically at due northeast, and I don't understand why anything would make it appear anywhere other than due northeast. This isn't.
All I can say is, if you can imagine a hula hoop over the top of it, over the top of the flat Earth.
Yeah.
You are so small, you would see that hula hoop as a line, because as that hula hoop should be, as it's going away from you, it should be bending around to the left geometrically. However, because your perspective is reducing, anything that would curve around to the left would come to straight, and it would be countered, and it would appear straight because of your field of view. Your limited field of view, your small field of view, it's perspective.
Sure, but our field of view changes when we turn our head.
Yes, but your static position on Earth and how the sun is acting over Earth does not. So it's still going to come from that direction regardless. And then it's when you turn your head over there, you can see it come from obviously direct east. It's still going to, like, if you look north, it's still going to appear to come from directly east. It's the natural topology.
But you started with, this is our perspective. This is relative to the observer. And now you've disconnected it from the observer, and you've tied it
It's not. You have eyes, and you have the topology of what you can see, the limit of what you can see. And you are limited on this ground.
But why? It seems arbitrary that if it's northeast, that it would appear to come from the east. Why would it appear to come from the east instead of the north?
Distance. That is the thing. It's distance. Because it's so far away, it's appearing to shrink. When you look over in that whole direction, even if you moved over to slightly halfway to be between, it would still appear to come from your right-hand side, because then you would be looking more over. You would put your central focus onto northeast.
But if I'm looking due north, now my focus isn't there anymore. It's changed.
I know. And it would still be coming in from over to your right-hand side, not north, not directly to north.
Are you suggesting that the direction it moves is somehow affecting where it appears to be from?
Of course. For all of us, if we all stood in one line, even though we've got different eyes, we would all see the same geometry of Earth, because we're all small.
Yeah, all right. You still you still haven't explained why it would appear due east instead of northeast. And you can't say perspective, because perspective is relative to the observer who can rotate their head.
Yes. And there will always be, no matter which way you look in, a reduction in your field of view. And you will be limited to what you see of the floor, which is a next thing, which is that formula that I was on about. But the sun coming in from northeast geometrically
here,
should appear from the left-hand side.
I'm
But
trying to understand from what you're saying why you think that it would appear to come from the east, even though it's actually northeast. It
okay,
doesn't. There's
okay,
no. It's just an arbitrary selection. It seems.
I've got to ask you a question then. Okay, so on the horizon line, you know the words horizon line.
Yeah.
Okay, where would just above the horizon, where the H is, where would you assume that would be?
And in your image there,
Yeah.
the H on horizon line, that's a slightly south of due east, right?
No, sorry. North is to the left, so you're on the equator. You're literally on the equator.
Yep.
And you're looking due east directly. On the H on your horizon, which is basically where to the furthest left point there, the first blue block from the land up, where do you think that is?
I'm maybe I'm not understanding what you're
It's your wider field of view. Basically, you're getting more land into there, and it's all reducing to converge to one point.
Yeah, but that is perspective, right? That's relative to the viewer. But when you're saying that it's going to be coming from the due east all the time, that's now you've disconnected it from perspective, because they can look a different direction.
It's not, because that's to do with distance. A 6-foot person or even someone up in a plane will not have enough height to be able to change the geometry of that massive arc of the circle.
But when you look at the sun, you're not looking at the sun on the entire arc. You're just taking an observation that of its current position. Where it's moving to or from is of no importance. It could be, zigzagging all around, but at the moment, if it's northeast, it's going to appear northeast. Just because in 10 minutes it's going to be slightly less northeast.
Yeah, I think, I don't know, have you seen solarography pinhole cameras? I'm sure you've dealt with them.
Yeah, pinhole cameras, yeah.
Yeah, if you can pull up any solarography, if you just go solarography in Google Images, and you'll see that, put it this way, what makes the bell shape? Why isn't it a circle? Because we're going round in a circle, aren't we?
We are.
So what makes the bell shape? Why is it belled?
All right, I'm looking for it. It's asking if I want sonography.
No,
but,
sorry.
Okay.
SOLARGRAPHY.
Let's see here. I can
Solargraphy. Let me pull up one which will show you the dates.
Yeah, I got. So there is a. Is that what you're talking about?
Yeah. So why is that not a circle? Because obviously on a globe, we're going around in a circle. Why not? Why is that bell shaped?
Because the cameras.
It's the perspective, isn't it?
Yeah, but
it's the perspective of the sun coming in.
But something on the left side there is still gonna appear on the left side.
Yeah, but look at the bell shape. Look at where it comes in on the left side and then arches upwards. That's not a circle. That's how perspective works, and that's not perspective of your eye or a lens. Yeah, that's not like a distortion of an eye or a lens, because that's a pinhole camera, which doesn't have any. That is the perspective distortion of distance.
Sure,
So I could now,
but it's
yeah,
not.
I could
But
now move that
is
pinhole
that
camera just
making?
slightly to the left, and it would still come up in that same place and be shifted. The whole image would be shifted over to the right. So that geometry of the sun moving over the earth is still not going to change, and your perspective view of that is still not going to change with you just moving a minor fraction of a couple of degrees of your head. It's still going to
Yeah.
come in and
So
appear to come in.
the whatever is, are these lights like stars, right?
No, that's the sun.
That's the
That's the
sun.
sun's over a whole year.
Oh,
So
okay,
that's it
okay.
moving. Yeah,
So
that's
all
it
right.
moving from
So
tropic to tropic.
there's a line coming. There's a looks like there's a silo maybe, right? There's a dome to the top of one of those things there, right? So that particular, there's several lines that go over the top of that. If you move the camera and rotate it and took a picture of it 45 degrees to the left, that same the arc would look different, but the position in relation to that dome would not
Yeah,
change.
yeah, exactly that. And
So
that's because it's coming from that direction. But because of distance, it appears east. But in fact, in reality, if you took a God view, if you then clicked your button to go into God mode game, you'll be able to see that it comes round. It again, you probably have to have a look at Walter Bislin's model. He does it and he shows both at the same time. So he shows where it should be coming
well,
from, the 45
well,
degree.
Walter Bislin's model does it by assuming bendy light,
Yes.
and which we do not have. We don't observe that, right? We don't have that massive
What's
amount
that
of
you're
bend.
seeing there? What's that in solography, if not bendy light?
No, that's a whole different thing, right? Bendy light would be light coming from one place and then turning a massive path while it's traveling and coming
No,
into into your eyes at a different angle from a different
no, it's an apparent
location.
thing. It's an apparent thing. That's not a physical bending of the light. It's a comparison between this apparent topology versus the geometric actual topology. Because obviously you know that train tracks in real life don't actually converge.
Yeah.
Yeah, so it's your eye makes that illusion. Now there is a set amount of distance or set amount of the Earth that you can see. So you are very limited on such a small Earth, and therefore there is a nested hierarchy, let's say, of perspective that you've got to consider. It's not just look at your eyes, then do an angular size. Because that is bendy light. That's the bendy light that you're on about there. Because what you can do in this model is you can go hour by hour. That is hour by hour. That's basically burning in light minute by minute. That any of the black bits in that solography is clouds getting in the way.
Sure.
So in some cases you can get really crisp ones which will show the thick line all the way through the day where it's been summer, and that's a proper bell shape in some places. So that's curving light due to perspective in my eyes. That's a recording of this curving light.
Yeah, but that still isn't explaining how it can appear to come from the wrong place.
Because of distance.
Distance
Because
doesn't
this
make
happens.
but distance doesn't make something appear to come from the wrong place. Right? Unless you have some evidence outside of this particular explanation that says just because it's far away, it's gonna appear to be coming from a different place.
Okay. The easiest way I'd be able to do it is if you can imagine the central perspective point. And again, no matter where, let's treat it like a plane.
Hold on.
A fight.
But you can't
Okay.
talk about perspective if it's not relative to just the viewer?
This is what I'm trying to put across. I need to introduce another object because you're not thinking about the sun and the sun and the topology and how that's working in comparison to you and everyone around you. So everyone within a certain distance are going to see a similar thing, even though everyone's got two sets of separate eyes. Do you understand that? So it's not like we can change the sun immediately just by moving our head just a slight distance across the horizon. It's still going to naturally on its topology, still going to be going around a whatever it would be on a flat Earth, is it 40,000 kilometers around the equator. So either way, on Walter Bisselin's model, you can see both light, both the bendy one and where it's actually coming into the dome, where he shows it, and the difference between the two. And the difference between the two, if he were to add another perspective view, which would reduce from the observer, then you would be able to make that light bend, or appear to bend, just like train tracks appear to bend towards each other, just like sun rays appear to diverge away from the sun. It's a perspective thing. You just need distance.
Yeah, I'm not buying that distance will make it appear in the wrong place. That's
okay. Well, let me walk you through this final analogy. If you're not going to get it from this, then no worries. I don't blame you. But I'd have to put together a mathematical something to show you. Which either way, I think it's a bit too late now. But if you imagine a fighter jet coming directly at us, perfectly on the equator, and we're looking directly east, it's coming perfectly directly east. We'll see it come straight in from the equator, go straight over our heads in a perfect line, and go straight over the other side and set in a perfect line directly. Yep, agreed?
Yep.
That's how it would happen. Yep. Okay, now, if we can imagine that the plane is coming into our view, let's say 1,000 miles away. Now, 1,000 miles away, the plane is coming into our view now 20 meters shifted to the left. Okay?
But the sun, we're not claiming the map isn't claiming the sun's 20 meters to the left. The map is claiming the sun
I'm trying to
way
explain the
farther.
concept here.
Okay.
Yeah, I'm trying to explain the concept. So 20 meters to the left. Yeah. And again, I fully understand exactly what you're saying. This is a huge shift. Okay. But I'm not talking 1,000 miles here either. And 1,000 miles to see a fighter jet is impossible anyway, because it's too small. But either way, just for conceptual purposes. Yeah. Just for conceptual purposes, if it's 1,000 miles away and it's 10 meters across to the left, in your field of view, it's still going to appear to come in directly east, but it's not until it gets close to you that you will realize that it's just slightly off to the left. And it's actually 20 meters off to the left. And then again, same thing, it will converge on your other horizon and you won't notice, and it will appear to go into west, directly west. So now it accentuate that even more. And there will be a point, obviously, where you'll notice it. But what I'm saying is the 45-degree marker is still hidden with 8,000 miles worth of distance. And it's countered.
Yeah,
that's what I'm saying.
All right, so
counter.
how far off of straight ahead was this plane?
How far off?
Yeah,
how
physically far off of the straight ahead line was it?
Well, it'd have to be 1,000 miles to the left, wouldn't it? If it was 45 degrees, if you're making a triangle.
Yeah, and so where would that plane appear to come from? 45 degrees to the left, or?
Well, no, that would you would notice that would appear to come in slightly more to the left, and then as it got closer to you, it would be even more and more noticeable. And that's what I'm saying. The closer it comes to you, it's even more noticeable. So the further away, it's even less noticeable. And that's the same as what I'm saying. 8,000 miles away to, let's say, 5,000 miles away. You're not going to know. It's going to be such a minute degree difference that your eyes will not be able to perceive the shift in path.
When it's... Yeah. All right. So hold on.
Just say you don't believe me.
I don't. So I did a test. I did my own test. Here's my setup. Do you see this here? Mm-hmm. This is on my kitchen table. I used my table is 39 inches wide, and that my pillar that my... So if you don't mind the stand-in sun being an actual globe instead of a sun, and it's too big, but to scale, but for an AE map, right? So this being an AE map, the equator is that string that's curving, right? And then that tape measure is due east. So what I'm going to do is I'm going to, on the lower right here, is where I'm going to put the camera, and I'm going to do observations from the lower right. Right, and I used the tape measure to get that curve of the yellow yarn. Right, is that making sense?
Yep. I think it does. I think it does. I think I know what you're saying. But
so here is from the observer there on the equator, which is the yellow yarn. And that tape measure is due east, and there we see the sun appearing not due east.
Yep.
Right.
Yep. And I see the problem straight away.
And I've moved
your camera lens.
Oh, hold on! I've moved it closer, and now camera lens or eyes. If I took the same camera.
No. I'm talking the size of it. I'm talking the size of it.
Yeah. All right. So
you would have to be less than a speck of dust.
All right. So here it's closer. I've moved it closer. It's still not due east. And then one more, moved it closer still.
Sorry, are you moving? You're moving the globe closer.
I'm moving the globe. Yeah. The stand-in sun is moving closer.
Yeah. And this is it. The thing you're not showing here is you've got a massive camera lens, which will probably be bigger than the biggest mountain on Earth.
Of course, yes.
Yeah, and then you've got a flat table with hardly any of the distance replicated. So if you were to replicate this, you would probably need about 1,000 actual miles, or maybe 500 miles of actual viewing distance to replicate what I'm telling you.
Okay, so the problem is these are just claims, and you don't have any actual evidence to support it.
No, I don't. It is a mechanism and a concept that I'm trying to put across the globers. Because you don't account for any of this. Put it this way: I have never seen a glober account for any of this, and you may say that guy.
You haven't established that it needs to be accounted for.
Okay, I mean, it's a facet of the flat Earth model.
It is, but it's not. From what I can tell, not based on observations of reality. It's based on an assertion or a hope or a claim that this is our explanation, and hopefully it works, but it's not. This is actually real physics.
Okay, I could say exactly the same thing about the next topic, and those exact words that you've just used, I could just replace it and say that's your model with gravity.
Yeah,
that's not real physics.
We're not there yet, real physics, right? We're not there yet, but
it's put it this way: there needs to be a mechanism. Flat earthers recognise that, and people have picked up on the ether band. People have picked up on topology.
So let's do this then. Let's do this. Let's take your idea and let's go to let's say 30 degrees south, 150 degrees east, right? So it's right near Sydney, Australia. right? And let's observe it on the day of the December solstice. Okay, so what would the prediction be using your whatever, what angle would it predict?
I would have to
see
concentrate on the maths. It is literally 3:36 in the morning.
Yeah.
You give me a task. I'm willing to show you the maths on this one thing.
Okay.
You give me the task, because I've done the maths for Wolfie on this, and my math showed the 0.3 deviation. And I can go through that, but it's an absolute mess of about 26 columns in Excel. So I can shorten that right down, and I actually use real refraction figures, everything in there. So I can give you more detail, put it that way, and you can give me a task then to do, and say, right, I'm going to pick 2 places and see whether your scheme works.
Okay. Well, I'll give you this example here then, just as a starting point, because again, using the any AE variant map. So I don't care if it's AE or Gleason, or if it's Antonio Subarat's, or just we don't know the map. I've seen people, we don't know the map, but the sun circles the North Pole, so it doesn't matter. This is what I think it predicts, using just putting the sun where at the subsolar point, right?
Sure. Yeah.
So 53 degrees northeast. So even more north than.
So sorry, you're saying this is the flat Earth, and then what is the actual recorded? That's what I need to know. Well, I'll be able to look it up, because you
shouldn't look that up. You
solstice,
you should run your math, get the answer, right, and then check to see, does it match observations? Because if it doesn't match observations, what do we say?
Sure,
it's not right.
It's not right, and that does lead onto a perfect segue into the next topic.
Did Joey Rocha showed up? Oh my goodness. Everybody's showing up. All right, so Earth is seriously flat. Before we move on a little bit, he says, "Sub to the plain truth, a hero on our flat Earth." So the plain truth, we're trying to set up with you, buddy. So send me an email, mctoon.
Shout out plain truth, definitely.
Yeah, mctoon@mctoon.net. Joey Rocha, answer your email. Fight the Flat Earth is trying to talk to you, and then Chris Bangert, for $5, says, perspective is nothing but linear transformations of scale with respect to distance from an observer. Quit making it something that it is not.
So stop looking in God view then.
Well, I don't think you made a case for why we don't see it. It seems arbitrary. If it's northeast, why doesn't it appear northeast? Why east versus north? I still don't see any
scale, distance. That's in my mind. In my mind, I'm saying it the opposite way. I'm saying they don't understand it. Put it this way: I always blame myself, as I've not explained it clear enough, obviously, and I do babble. Everyone knows that I do babble on a bit, and I don't think I put it across clear enough. But obviously, maths, tells the game. So you do have predictive formulas for this, because I gotta be honest, I've never seen a flat earther show up with any math ever like that worked. So okay, I mean, you mustn't have had.
I appreciate that you have that, at least.
Yeah, there definitely is. There's one formula which I've used, and it gives you the results that you need on a geometric point of view. But bear in mind what I've just literally said, everything else there needs to be accounted for. And in designing games, have you ever come across 3D plane clipping?
I don't design games. Yeah, you said that in the rap. I don't.
Oh, right. Okay, I've absolutely blagged that then and made that up.
Yeah, I write email software.
Oh, okay.
So
Right.
that's a very
Are
different.
you
In fact,
playing games with emails though? I see your
I
game.
do play some games. For research, I've done all the things that people should not do, and we have a whole bunch of different email addresses that we get stuff to. That is kind of fun sometimes, but to read because we get all sorts of crazy emails. So, and I see all of the everything email, the scams, the naughty stuff, the phishing attacks, all that. So we see those all the time. So
Yeah, we used to use for mailing. It was something monkey. Was it Spider Monkey or Survey Monkey or something like that?
Survey
used to-
Monkey. And
Yeah, it wasn't actually a survey.
There's Mailchimp.
Mailchimp. It was Mailchimp.
Yep,
Of course, it was Monkey.
They're good.
I'm
We
just
like them.
thinking Monkey. Yeah, it's just because I'm on a Monkey stream. I mean, yeah, Globus stream. I'm joking.
So
Anyway,
Jose Meza says you are super chill Glober bro. Shout out to you. Well, thanks, Jose. Maybe you can be
shout
on,
out Jose Menza.
join sometime.
Boom.
So
Double boomer.
all right.
Okay, so you don't believe me. I think we should lock that off.
That's fine. Yeah, that's fine. I want to be sensitive to your time. It's very late for you. So, how much time do you want to spend on this next topic?
I'm gonna put it out there in as much as when I first come here, I said, look, I don't actually believe either model 100%. And my true honest opinion is no one in here can actually prove either model to anyone else. And anyone's just kidding. It's all belief. It's all belief.
Yeah, well,
regardless of what
science doesn't prove, right?
Yeah, no, it's exactly that. And that's the thing. When you can say, yeah, we got a preponderance of evidence, but is it falsified against the flat Earth? Is the thing. So you can design a model, and this is my whole point of view from when I started doing debates. My very first one was with Schrödinger's cat on non-sec, and that bit's true in the rap though. That was their last flat Earth debate before they done all their breakup.
Oh, it was okay. You
last
broke
proper
them.
one.
You broke them.
Yeah.
GPS says this is fun.
Yeah, GPS.
Yeah, I think
he loves the Gleem. Yeah. But anyway, getting back to the model. So I could say to you, and this is exactly the same thing I try to take him through, is that we could be the last two human beings living on Earth and lose all of our memory, wake up on a deserted island. Let's just pretend we've got wives so we can procreate and carry on. And you take one side of the island, I take the other side, and we're best mates. And we just sit there one day and we think, what shape is the Earth? And we can literally sit down together and go, right, okay, for the next X amount of years, I'm going to design a globe model and see whether that works. And then I can go over the other side of the island and say, right, for the next 10 years, I'm going to design a flat Earth model and see if that works. Now, what I can guarantee is at the end of those 10 years, when they both come back together and say, right, let's compare models, let's truly find what we're really on, they would both have a working model, which would describe reality to a T, because they're both working from the same observed reality and the same thing. So the model has been designed from that, rather than the model is such and we are just recording that. Now, what's actually happened is the flat earthers just got neglected, and all globe earthers are doing at the moment is just basically going, see, it's a globe earth. Our maths works on a local scale. We can predict this, we can predict that. Yes, because you've had years and years, thousands of years of scientists, great people, basically designing this model. And when they found little errors, they've pushed the sun back, they've modified the theories and whatnot. And you've finally come to a set of theories where in the solar system, you can pretty much describe everything. Yeah. But now this is where we wouldn't where if we were both on an island, we wouldn't have this technology. We would still be in, let's say, the 1930s. We would have just been able to make something like a telescope. But let's say that up until the 1930s, everything was mapped out. It was all working perfectly fine with Newton's gravity. Everything was chilled. Sorry, even with Einstein's gravity, because that had come in by then. So everything was working good. Now, they upgraded their microscopic technology and also the telescopes. So they got much more powerful and you can see further. And what they previously thought was just blobs of light in the sky actually turned out to be full on galaxies. And that's when they started to measure these galaxies using exactly the same theories that have just been built on the solar system, which work perfectly fine on the solar system. And these exact same theories are failing consistently by a factor of 10. And those theories are Kepler's laws, Newton's laws of motion, and Einstein's relativity. So again, time goes on, or as well, time goes on, and down in the particle scale, quantum field theories come into play, and gravity is no longer included in the standard model, or standard particle model, should I say, because number one, it's too small to even matter anyway, but it's incompatible. Obviously, we know the quantum versus relativity incompatibility. So to say that, yeah, we've got this model, and on the same hand as well, that so much relies on this one gravity theory, or the theory of gravity in its whole nutshell, whatever which one you want to use. And you use this same theory and it fails at very small scales and it fails at very large scales, and it only actually works in the scale that you've designed it from, then what does that say to you?
So yeah, we got to go over these failures and see what's.
Is it wrong though? Because remember what you said to me about the if the maths don't work about that sun not being able to come in with perspective on the 45 degrees, it's wrong. And I agree. If the maths don't work, then it is wrong.
Yeah.
But
yeah.
on the same hand, gravity is, put it this way, we're talking all speculation with the flat earth model because it's new, so to say. No one's worked on it for God knows how many years. We've got Samuel Rowbotham.
Well, it ain't that new.
They've got.
Everybody's always running around like Joey Rocha. Our ancient cultures, everybody knew it was flat. So it's not that new.
Yeah, but you've got to understand that there's been a shift. There's been a massive shift where it hasn't been concentrated on.
Yeah, the reason why is it didn't work.
Right? That is a huge statement. That is a very bold statement.
I don't think it's bold at all, because like, you know, the sunrise predictions, the maps, the distances between places, like, you know, Tiger Dan is a pretty great example of, you know, he tried to make it work. He tried to make
he's rubbish.
And it didn't.
Yeah, he's rubbish. But can I just two bullets from without even pulling the guns out the holsters? Number one.
Feet?
No. I'm gonna just bend them up and pull the triggers and just hit and hope.
Okay.
Yeah. So the second point I think I'll attack first, where you said it didn't work. Eratosthenes designed, or he was the inventor of longitude and latitude, and he designed that on the flat Earth map without any account for curvature. Okay, and you can look this up, Eratosthenes map.
Okay.
Look it up freely yourself.
What was the range of his map?
It was very poor because it didn't include any of the Americans and Americanas.
So it was a rather small area that it covered. So
it was Europe, Asia, and Africa. So it was like everywhere apart from South America, North America, because that wasn't discovered. Yeah. So that was that one, and then you said something, and it didn't work on sun tracking. Now,
well, no, the sun tracking that we were talking about earlier.
But the whole sun tracking started with flat earthers, Thales of Maltus and Anaxander of Maltus. They were the first people who predicted an eclipse, because they were the first people who said, right, we're going to start tracking this.
Oh yeah, they used the Sorrow cycle, which is fine.
No.
Right?
No, they did not. No, if you look up Aries, there it was an undetermined cycle of what they've actually used, and I will say 100% there is ambiguity surrounded by it, because a lot of the records have been moved. Thales was around. This was 585 BC. So we're talking a good 300 years before Eratosthenes, and there's literally hardly anything left of Eratosthenes, let alone 200-300 years before him. So either
Well,
way,
yeah, and of course, there's a lot of question about these ancient people like this, but
but the whole thing, Airy done a big speech on it. He's done a lecture on it. George Airy, he's astronomer royal. You obviously know him. But yeah, so they started the eclipse. They started recording the sun and its position, and it turns out it doesn't matter about the shape of Earth. It is a mathematical equation based on pi. It's
all
absolutely
right.
nothing
So,
to do with the shape. It's a
but
cycle.
you can see over my shoulder here these
Mm-hmm.
maps, right? These are not based on flat, so I don't know if it matters a whole lot what right what they
What
were.
do you mean? Sorry. What
Well,
maps?
oh yeah, you probably can't see. So I
Are
have
they are
some
they your ones? They're your ones you done it for Wolfie's thingy, aren't it? Where you put it around the tent thing.
flat out hero. Yeah.
Flat Hero. Yeah. That's it. You know, I remember that. That was one of the first videos I ever watched of you. That made me subscribe to you.
Oh,
Put it that way.
well, thanks.
Yeah.
That's coming up this month. Will be 1 year when I did the first one of those. So
Wow.
those maps are based on a sphere, and they, when you connect them together, you can't do it on the floor. That's why I did it on I built that little structure for them to sit on,
Sure.
because they're all they wrap around to each other. So that's what I'm talking about when I say maps, right? The navigation. And so what Eratosthenes or somebody else did, I don't, they weren't doing a
Yeah.
map of the whole
Martin
world.
Belhaim.
They weren't navigating with it over large distances like that, right? So
No, they was only figuring out the curve of the Earth. Wink, wink. But anyway,
so
anyway, yeah.
let
So
me. All
that
right.
was just shooting off those two comments you made. Let's go on to
Yeah. All
the
right.
gravity wise,
All right.
because
Hold on.
as I
Let me,
say,
before we
oh,
move
go on,
on
sorry.
here, I want to say NANA for $6.66. Hail Santa. He doesn't like what you're saying. I won't repeat it.
No, don't worry, I'm thick-skinned. Seriously,
No. He's saying you're lying. So
it doesn't matter. It
and
doesn't
then
matter. I get it daily.
I know he used a different word. I'm not going to say. Angel Gary says, what predictions are there for flat Earth? And then one more here from FTFE says, for 20 pounds. Thank you very much. Flat Earth doesn't work on any level. Gravity is still part of our model, but our explanation of it has advanced. So that's what he says. So I think that's a good segue to I know what you're headed for here. So
The core of it is that there's so much based, including shape, on gravity, and yet it fails in large scale distances and small scale distances. And if you know anything about scale invariance or general covariance or even relativity's first postulate, it basically says that all laws of physics must work in all coordinate frames. And at the end of the day, in the coordinate frame of a rotating galaxy far away, it doesn't work. And that's why you need dark matter and dark energy. And you can say, okay, yeah, if it's a small problem, a little tweak or something of the equations that you can do. But this is like 95% of the model needs to be this invisible dark stuff to make it match observed reality. And that's a big error. That's a massive error. And that's one of the things that I despise against globe earthers saying, we've got a working model, because you haven't. And then when you say gravity, it works, we can predict this. And they don't know anything about this. And it's a peer-reviewed thing that's been going since 1930. It is actually a record breaker. It's the longest outstanding problem of physics, is this dark matter, which is the galaxy rotating too fast.
yeah.
So the core of it is I'm not saying that oh, this debunks the globe and that's it. Because I know your stance and everybody else's stance is exactly from the Newton to Einstein stance of, okay, we've designed a certain physics, we know how this works. And then when we've tried it out on this scale, it's not worked. For example, with the Newton and Einstein crossover, where he just slightly modified that mercury perihelion. And literally, all it needs, well, it doesn't need a minor modification now. It just needs a major modification to be able to work in the outside universe to either get rid or to disclose this dark matter, dark energy.
Well, I don't disagree that there is some things that we don't understand, right? That's pretty obvious. So you had linked a couple things. I didn't get too far in. I knew what you're talking about, right? I have this one here by what was her name? Is the main author Vera Rubin.
Yes, Vera Rubin.
Vera Rubin, yeah, great stuff that she did. So,
I swear I was so gutted, and I reckon Simon Dan, if he's in the chat, I don't know whether he is, but
I haven't seen
he deserved that Jesuit diss because he did not mention her in his 5 favorite astronomers, and she literally, from a globe earther point of view, she probably discovered more of the universe than anybody else on Earth, including Tycho Brahe.
She was busy. She did good work. So the dark matter, dark energy is a problem. Is it that we don't understand things? I don't see it as that breaks everything, and right, and neither do scientists, right? They're like, yeah, this is something we don't understand. But when Fermi invented the neutrino, right, that was because there was a problem. There was not enough energy in the system. It was missing. There was something missing. So he just invented out of but no, they figured it out. It's not either, right? So they invented an idea, just came out of nowhere. Let's imagine that there's a particle that comes out of beta decay, and whatever, they just made it up. And how long did it take? It took decades, and they confirmed neutrinos actually are particles. They actually exist. And yesterday, this is cool. Yesterday, I was at the Sudan mine in Sudan, Minnesota, up north by Hibbing and in northern Minnesota, where Fermi, who named neutrino, Fermilab used to be sending their beam of neutrinos to the detector in down in the mine, 2,300 feet below the surface. They're about half a mile deep. And I saw they didn't let us go into the actual room there, but you could, like, I peeked around, and we're getting on the elevator, and I peeked around the thing, and I saw the giant doors to the room there. So I only know about that mine because of Fermilab. So I actually got their little brochure thing on the project. Won't do you much good to see it, but it was cool. So they invented this solution to a problem, invented a particle, and then it turned out to be correct, and it answered all that mismatch in the numbers, right? Mm-hmm. So the dark matter, dark energy, it's the same thing. They're just inventing stuff and then working a hypothesis around it to see if it works, right? And so there's other things people have. I don't know if you've read. There's some other things. I kind of liked it. That gravity works differently at different distances was one other. Idea.
Yeah, I've seen a lot of theories. Yeah.
They for some reason, I didn't look into why, but they gave up on that particular one for the most part.
Yeah, no, they were going more down the superconductivity type gravity, supergravity route, where there would be a different scale, and even they've gone the opposite end. They've gone Eric Verlind. He's done entropic gravity, which basically removes gravity completely as a fundamental force from the system. It's actually a second order effect from thermodynamic entropy. And what that basically is he's took it right the way back to bare particle physics. And he's basically assumed that all of space is a bubble in thermodynamic quantum fluctuations, and not assumed gravity, but just used that. And he's managed to resolve dark matter just by removing gravity. However, it was part of the MOND. I don't know whether you're aware of that, which is the modified Newtonian dynamics.
Yep.
Which actually it went through and it passed stage 1 of peer review, but then failed, or got stuck, should I say?
Yeah.
And he's been recently back in the news saying that he's changed the theory, he's modified the theory slightly. But again, that is somebody that is he's from the University of Amsterdam. He's a top level physicist. He's done loads of lectures, loads of talks. And he's literally saying, okay, I'm approaching it from a different point of view where there is no gravity in the first place at all. It's all just entropy and thermodynamics.
Okay.
And it's a resolution to the problem, or a suggested resolution.
Yeah, but it's another hypothesis.
Yeah, and there are also as well hypotheses that neutrinos are ether. There is a definite thing, close link between gravity and ether. There is a definite close link. And what you're saying there, where, we invent these new particles and then we find them, with dark matter and dark energy, I don't think it's going to be like that. It's a bit different than that.
Yeah, it certainly could be.
Yeah,
and,
it's because
it's harder because it doesn't seem like the type of thing that is as easy to see, right? Is easy to test for. And that was actually, they did also have a dark matter test at the Sudan mine that came up empty in the end.
Yeah. Well, this is it. That's 90 years after looking for it, and they haven't found anything.
You have a message from, hold on, the Plain Truth. Don't be disturbed by this. The Plain Truth says, if I were a woman, I'd be throwing my panties at Gleem.
Man. Check out his karaoke anyway.
I've seen his. I've watched his karaoke briefly. It was country, so maybe he does some non-country. So I felt a little ill right away. So
let the country play. I'm a reggae guy, and let the country play.
I'll take reggae.
Right.
Well, I don't know.
Well, let me put it now. Let me spin it onto a flat Earth thing, and we'll get back to Vera Rubin's quote.
Okay.
Because I can easily understand why you could say that's such a cherry pick out of context.
Hold on, I have it.
Yeah, but I'm not going to say it. What I'm going to
in yellow. I knew what you're going to do right there. I didn't let people read it maybe, but I think I have it. Yeah.
Well, the core thing is you must understand, okay, and this is a thought, no calculations have taken place. I would love to be able to steal Barney Tierspell's brain and time and basically go through the calculations required for this to be able to configure this. But if you can imagine the galaxy spinning, I'm trying to think of an even simpler solution than inventing some dark invisible stuff that we can't see, that's just as much or just as well say God did it. Yeah, because 95% of the universe has to be 95% of invisible, undetectable stuff, which is exactly the same as what God is. God is invisible, undetectable, but he's always there. He's everywhere.
Mm.
Yeah. So either way, without resorting to that, what is the only other solution apart from the route that Eric Verlind took, as in go back to particle physics and whatnot? And in my mind, I thought, right, could this just be a scale invariance issue? Do you understand what I mean when I just say that?
Yeah, you should explain a little more.
Okay, so if we imagine a record player playing a record 1 meter away from you, and it going at just normal 33 RPM, or it would actually be the faster one, but let's say 33 RPM. If you're looking at that record spinning, let's say you put a marker on it, like what DJs do for when they're marking up their tracks or doing scratches. So you've got this label spinning around at 33 RPM. And what you can do is you can, and this is magic, and this will sound weird, but you can magically make that record player and the vinyl spinning on it double the size and take it double the distance, and through angular size, it will look identical, but the spin of it going round will not match. Okay? So what I'm basically saying is that the galaxies spin too fast at the moment based on the distance that we've got them, as well as based on how much mass we've got them. Okay? So if we made the mass smaller, okay, and dragged it in towards us, as in made the whole scale smaller, then it would go faster. The mass would work. There would be a sweet spot as it comes nearer to Earth where the actual, even if we conclude that gravity is real, yeah, and all ball physics work, yeah, and let's even forget the flat Earth from this bit. If all ball physics work to resolve the dark matter issue without invoking magic, dark magic, then if we were to, let's say we got the scale wrong, we accidentally see these these galaxies, and we've said, based on our current maths or our Doppler redshift Doppler effect, these galaxies are X amount of million light years away. If they were X amount nearer, the spin would match, because they would have to be then smaller in mass and therefore allowed to be go round faster without shooting out and separating, let's say. Do you understand that, or did I babble all of that?
I see where you're going. I think you're trying to bring it all closer, right?
And that is the point.
And then suggesting that the dark matter problem with the galaxy spinning too quickly would be fixed because the scale got smaller. Is that what you're getting at?
Yes. So if we drag the whole universe in and shrunk it.
Did you do any math on that, or you just kind of
very basic math that I cannot say was any good? What I basically done is I took the total observable universe, which is 93 million light years, and I worked it out on circles.
Hold on. The observable universe is 93 million light years?
Something like that.
I think
maybe billion light years.
I think it's 60 billion is what is the observable
size.
That's
the diameter.
Yeah.
I don't know. Let me.
I don't think that particularly matters to this conversation.
Yeah, but all I tried to do is I think I got a circle, and I said the circle radius between us and this galaxy, and that was a factor of 10 wrong in that paper that I done, Vera Rubin's paper. It was a factor of 10 wrong. So if you were to consider that was a factor of 10, you then have to times that, kind of like the inverse square law, as you go out. So all of your distances are going to be that far wrong, but then times by 10 all the time in the ring going out. And I come up with some maths, and again, absolute nonsense. That's why I need either somebody's help with it, or to actually just sit down and learn how to do it, because I think it's a pretty difficult thing to do. Well, put it this way, I will say that there's a guy called Kai, who was in Nathan's live chat for a good year. I haven't seen him for a while, and he's got a degree in maths. And I begged him for weeks on end, and he was literally give the impression I wouldn't have a first clue on how to do it. and that was someone with a maths degree. So I'm not that smart.
Okay.
Put it that way.
All right.
Yeah.
So, you're all right. So you're saying you shrink it down,
So
and maybe
shrink it down.
maybe things will work better. All right. So how far do we have to shrink it down?
No, well, it's conceptual. So I can't give you numbers and say, right, yeah, it needs to be this size. But what the core aspect is, what I'm getting at is you've got two different models, the flat Earth and the globe Earth, and they've got two different facets. One has got a vast and wide, expansive universe, and the other have got a small and local within the dome type. Yeah.
Yeah.
Now, if you've based your model on a local basis on the solar system, then you've tested on long distance, and it's basically saying, no, wait there, your maths are wrong. It's smaller than what it is. Then that would be reason enough to then investigate, is it a flat Earth? That is my ultimate standpoint.
Yeah, the distances are much off. I can't say much enough. Because, all right, so here's the paper you brought up. They're talking about things that are millions of parsecs away, or not millions. I don't know. The distances they're talking about is just really big.
Astronomically.
Yeah. And so to bring it to say, well, the math on dark matter doesn't work, therefore we're going to collapse everything down to flat Earth. I don't think that follows. I think there's maybe a billion other hypotheses we could come up with before we'd come up with flat Earth.
Sure. And you have done. I mean, you've invented this dark matter stuff. Put it this way, Vera Rubin
I don't
had
get
no
credit
other
for
option.
that. Vera gets credit for that, or somebody else, right? So,
yeah. No, you've had to. I mean, the model has had to. The observed reality has said, look, this is right. This is what it is. Your actual theories about me are wrong. And if you can understand, going back to our island where we've just built some models, that's how science works. We record nature, and then we build our models from what nature is telling us. Now, when it comes to the likes of this, it seems we've spun around, and instead of change our complete theories totally to match what nature says, we've had to add something to nature and pretend she's hiding something. She's hid this dark matter. We just can't see it. We've got to pray 3 times or look in the mirror. Something like that.
Yeah. All right. Well, let me catch up on a couple things here quick. Earth is seriously flat said, are you enjoying your wonderful globe exorcism? Lori, Lahatiaho. Sorry, Lori, I got it wrong. Lahatu says, cool story, Gleem, but the FE model works on no scale at all. I'm with her there. Earth is seriously flat. Puss in Boots again says, globe zombies don't have a working model either. Alchemist, for 2 Australians, says, what did LIGO detect? And then Bubble Burster says, I'm disappointed Gleem mentions this FE math he claims to have but refuses to show it. I'm genuinely curious. Never seen FE math before. And I gotta say, yeah, I'm kind of curious about that.
I'll drop you I'll drop you some. I'll give you the angles to Polaris. There we go. I'll give you your free trial, and then you've got to subscribe to me, monthly fee, and I'll give you the knowledge.
Dude, I'm already a subscriber, but you only have like 3 videos. But
I know that's all you get for your money.
Sorry.
I'm only joking. I ain't even monetized. I don't think.
Yeah, you need a few more subs and views. So the thing is, the scale, everything has to be so much different, right? And things like the speed of light are not.
Yes.
They're not negotiable, really. I mean, you gotta really do an awful lot to say the speed of light is different than what we
That's
think.
A big question. That's a big question, though, because put it this way, on that point, that's a massive point, though, because the speed of light was fixed by Einstein, and must have been fixed by Einstein against a lot of people's will. And at the end of the day, he was basing it on free space, as in there is no properties of space. And now our theories are no, there is properties of space. There's this dark energy stuff, there's this dark matter stuff that we weren't aware of. So you can't have it both ways. You can't have working maths saying there's nothing in that medium and then say, oh, the medium doesn't work, or the lack of medium doesn't work. So we need to now add something into that medium to make it work. Do you understand that?
Yeah. I
So
don't
the speed
see.
of light
Yeah,
will
yeah,
slow down in that medium.
Einstein didn't measure it. He said it's constant
Yeah,
in a
no,
frame of reference.
I'm
right?
fully aware of the history. Lewis Essen, look up that guy. He is the guy.
He is the guy. What?
He is the guy that opposed Einstein officially and got told to wind his neck back in or he would lose his job.
Okay.
And he was one of Einstein's peer. He was the inventor of the atomic clock, the first guy who measured accurately the speed of light with an atomic clock,
Okay.
and the guy who invented international timing standards. Einstein looked up to him, and he hated Einstein for relativity. It's public knowledge. That's no conspiracy.
Okay.
Hashtag no conspiracy.
Yeah, I don't know what the because I don't think Einstein was responsible for measuring the speed of light.
No, he fixed it. That was the point. He fixed it.
What do you mean?
And
he
I don't
fixed it.
It's his second postulate of relativity.
But he didn't fix it. The speed of light is the speed of light. His opinion of it doesn't change it.
It does when you're saying that it's the same in all relative frames. Lewis Essen had a problem with relativity on a whole.
Yeah. But now
wrote
in the meantime, there have been an
papers.
awful lot of experiments that have confirmed what Einstein did, right? So did any of Lewis Essen's, I don't know who he is, did his stuff
These are the forefathers of these are the engineers. Einstein was the mathematician afterwards that says, I think this happens.
Yeah. But what happened then, right? Science didn't stop, right? People have
I mean,
done stuff since then and confirmed over and over what Einstein, had in his theory.
Yeah, and again, that can work as a close approximation in a scale that's on a close scale. It fails on the galaxy rotation curves.
The speed of light fails on the galaxy rotation curve?
Well, it's to do with the redshift Doppler effect and the measuring tool used to measure the velocity. So yes, and there is other issues as well. If it was just a one-off, then you could just say, there's nothing into that. But Holton Arp, he used to, he's got multiple stars named after him. He used to be an astronomer, and he worked on weird quasars. Yeah. And he found that there was an anomaly with two quasars. The actual redshift reading they would get off of two near each other. One was saying that it should be shooting away from you at X amount of million miles per hour. And the other one said it should be static or almost static, moving away, but not as quick as the other one. And then he noticed that they were actually exchanging matter. So instead of the redshift being the velocity of it moving away from you, it was actually the velocity or the color shift in its formation. If you understand that, when it forms, it's going to get brighter, and when they're exchanging matter, they're going to go into supernova, whatever it goes into that. So that's what he was saying. He was saying more that we may have our distances wrong because we've accounted for all these quasars, and the quasars we use as standard candles to basically say, yep, these quasars are moving back at X amount of million whatever, which was still under the speed of light in most cases. And if it turns out that could be all wrong. and he put a paper towards very high up university astronomer, Chakisandra, Sandre Chakisandra. I think I've totally messed that up, but he's a very high up mathematician. He was like one of the geniuses, and he sent the paper back written on the top, "This is beyond my imagination and comprehension," because he was basically saying we could have the whole system of measurement wrong,
Yeah.
and
All
he
right.
would.
So
He was then banned from all telescopes. So.
okay. So yeah, there's history and there's whatever. Here's the thing, right or wrong, I don't know. This is all stuff that I'm not familiar with. None of this even is remotely acceptable to flat Earth, right? Because these are things that are way distant, right? And so yeah, if we're talking about there's problems with things that are, many light years away, then that's fine. We can discuss them, and the people that work on that can all try to figure out what they're doing. But none of this works with the flat Earth, right?
No,
so
this is the point.
And that's all great. So thank you. And there's a whole bunch of flat earthers in the chat, and they're like, yeah,
no,
yeah,
it's not that.
And
No,
I'm like,
I
hey,
disagree with you. I really disagree with you there. Really do disagree with you, because
if it's small and local, then you have to not have things very distant.
Let me give you what I call the flock mock paradox, and this sums up my whole belief of where a load of people get together and they mock other people for their beliefs, not knowing things. Put it that way. And I'm stupid, so I don't know things. So I'm not proclaiming to be the top boy here, but I see it everywhere. Where you were basically saying, look, well, if you're trusting these, yeah, there's some minor modifications that needs to take place, but I've just basically told you that people have found that there's massive measurement issues, which could be wrong, which means we've got the whole universe wrong. Now, the flock mock paradox bit is, if I were to say to you, if I was a flat earther and I come to you and I said, MC Toon, I can prove to you that the earth is flat right here, right now, and I will walk you around every square meter of the earth with a 1 meter ruler, and I will show you empirically the earth is net flat. Okay, you will laugh at me, wouldn't you? You would say, a 1 meter ruler, what are you on about? You need something with a greater scale, because a 1 meter ruler will not identify any curvature. Do you understand that?
Yeah.
And therefore there will be no error. So now what we're saying is gravity works as a 1 meter ruler inside the solar system, but once you get it on a larger scale, it fails. So although I can prove to you empirically that the earth is flat with a 1 meter ruler, yeah, in the same way you can prove to me the globe is a globe because gravity works in the solar system. But on a large distance scale, that's not what we see in reality. So I'm saying there is two different models. One is a vast and wide universe. One is a small and local universe. The data that the globe earthers are getting peer reviewed is saying it's a small and local universe, not a vast and wide one. That is the ultimate point I'm making.
But how small and local are you suggesting?
Not vast and wide. I haven't got figures for you. It's just to say, is this a point of discussion or not? And I think it is, personally, always have. And not a lot of globe earthers even know about these problems, even know that 95% of the model is made up. Has to be made up, because that's what the data is saying.
95%. See, saying 95% of the model is made up is a bit dishonest, I think, right? Because 95% of matter needs to be invisible, that doesn't mean 95% of the model was made up, right?
Well, the model is completely failed. Let's put it that way. It's been falsified.
I don't agree at all, and I don't think that there's a whole lot of people that agree with you either.
I know, because right. There's no other way other than thinking of flat Earth.
But you have to take the distances in this paper and throw them out. That this is your citation.
No. I believe the citation, But that's what I'm saying. The citation is coming back and saying, based on our globe model, this is coming up different. The scales are coming up different. So in order to modify that, I now have to add a sixth worth of that matter to match the amount of gravity that we should be seeing. And call it invisible dark stuff.
Don't mix in dark energy with dark matter, right?
No, that was just dark matter. Dark energy came from dark matter. Dark matter is the core and only problem. That's
dark matter to dark energy dark matter to matter is about 6-to-1, right?
Yeah.
So
that's it. And then but dark energy comes from dark matter, because what they had to do is they added up all the matter they can see plus all of the dark matter, and then reversed it on how much energy would needed to be to expand it to where we are now. And when they extrapolated the numbers and reversed it back, it was 10 to the 120 wrong. And that's where the dark energy had to come in.
Yeah, the dark energy is for the expansion of the universe.
Yeah, the expansion. Exactly, that's it.
Yeah, somebody's asking, can we get a citation for those that came late?
Citation for what?
Yeah, I don't... it's...
Galaxy rotation curve problem.
Yeah,
Vera Rubin. Yeah, that's what we're really talking about. But can you read the quote? Because that is a slightly different problem called the horizon problem, which is where we look in all directions and it looks homogeneous, basically the same density in all directions.
All right. Is that what that quote is about?
Yeah. She's basically, just to fill everyone in, Vera Rubin is Richard Feynman's student. And she was tasked with documenting all galaxy rotation spins with Kent Ford in 1968 or something. And then they finally published a paper in 1980s. And it was one of the most documented and extensive studies. And no one believed her, because what she was saying is that Kepler's laws and the gravity laws of motion, they're not matching up. Something's not right, and it wasn't right on a massive scale. And it's not something that we can just say, right, yeah, we'll just modify or just wait until something. We have to put a placeholder in place because it's that big. And that's when dark matter was born. Obviously, people peer reviewed it. They didn't believe her at all when she published it, and it took a few years for it to get accepted, and people peer reviewed it and said, okay, yeah, we're measuring the same thing. So that is the core of it. That is the core of it. But if you can read the quote, you can.
So we know very little about the universe, Dr. Rubin said in an interview. Am I right here? Is this the right one?
Yeah.
For Lonely Hearts of the Cosmos. I love this title. Lonely Hearts of the Cosmos, the story of the scientific quest for the secret of the universe. And back to quoting her, I personally don't believe it's uniform in the same everywhere. That's like saying the Earth is flat.
Now, just to extend that, somebody on one hand can say, oh, she's just doing a flippant comment to match something against something that's ridiculous. Okay, but I truly think that she's saying, personally, I don't believe the actual Earth is flat, but what I'm actually recording here would suggest something like the Earth is flat. But it's obviously not flat, so we need to think up another suggestion. And that was why dark matter was born.
And I'm with her.
Yeah. And that's it. And it's to do with belief. And in my eyes, it's the same as Christian saying, I don't care whether I can actually prove God. I know he exists. He's there. And he makes up all things. He lives through all different things, but he's invisible and undetectable. And that's what I really don't get. I get it, because I reckon science and religion are synonymous of each other. They're the same thing, just using different labels and concepts to describe exactly the same thing. Yeah. One's physical, one's not.
Yeah, I disagree on that, of course, and scientists generally do it's the point of science is to in some of the points of science is to remove bias, to remove religion from it, right? It's an exploration of the physical, not the metaphysical, which is what religion talks about. So,
Yeah, no, definitely that is the branch.
And
Yeah.
and in general, I don't think that religion and science are at odds with each other because they don't study the same thing. So, yeah, and I don't know. We didn't get into a lot of it, and
Yeah,
I don't
no,
know.
that's it. I think,
I know
yeah,
it's late for
I
you,
think it's hit a wall. It's
yeah,
hit a
we
wall.
have.
But the core things, the two things I wanted to try and put across there is that perspective is never is just dashed away and never accounted for in any globe earthers analysis
I
of pictures that
I
involve
always
perspective.
include perspective because it's easy to calculate.
Yeah, I see it in an orthographic view, yes, but not in the view where I was showing where two objects can hide something, and on actual ones where they're close to the actual water. So there is wave height that you are not getting over, and it's still classed as curve. Put it that way. And the second one is that the globe Earth model. Stop talking like you've got a working perfect model when you haven't.
Yeah, so yeah, galaxies are a problem, but locally, what problems are there? And I've not
Down,
seen
da,
significant
down at
things
the
locally.
Yeah, down at the small scale, it doesn't really matter. But obviously, you've got the difference between quantum theory. I mean, the standard model
Yes.
is built off quantum field theory, and it's exactly that. This is the crossover part of physics, where you just said, "Yeah, a guy invents a particle, a physical thing, and then we work to try and calculate something that would match that particle." And it's exactly that. You could go down the Nathan Oakley route and say that's reification. You're actually reifying something that didn't exist or doesn't exist, and then you're ascribing something to it, which it should be the opposite way round. You measure it and then ascribe it. But obviously, predictions happen in science. Theoretical physics happens.
Yeah.
But yeah, it's a field. And Ken Wheeler goes on about this, that physics neglects the field because it doesn't know how to deal with it, because it's a dynamic scalar field. And that's exactly what
What field?
any field, ether field, electric field, magnetic field,
Physics
it,
ignores it or rejects
it
it?
put it this way, they have invested more in the gravity field than they have in other fields in investigating plasma, let's say, from an electric universe point of view.
Okay.
So they put it this way, I understand why, because physics has to deal with something physical in order for it to work.
Yeah.
So just like an electron is said to have a shell and this, that, and the other, but obviously in quantum field theory, it's a field.
Yeah, I don't know if I see that being ignored. Right? They talk about when they shortly after the Higgs boson, there was an awful lot of talk about fields.
Yeah, it's been a neglected thing because it's not a physical thing,
and
it's too difficult to study.
And when I was taking electrical engineering classes, and there was an awful lot of talk about fields.
Definitely.
So I don't.
Definitely. I mean,
I don't know why you think that's missing.
I'm not saying it's completely neglected science, or we wouldn't have computers. But I'm saying gravity has taken the lead. If you look at how much money is pumped into research at the moment, and you will find that gravity is taking up a massive amount. Gravitational waves and
sure, LEGO and
yeah, and multiple like satellites and
so,
whatnot. All science is involved around gravity. Put it that way, in the investigations of gravity, Solar Parker probe and whatnot.
Sure. So
All
I don't
of
know
that.
why Demonic Davros is asking if you know who Lord Kelvin is. He's asked a couple times. I don't know why.
Of course. Yeah, of course. He's
You've gone around with him a few times?
no, Lord Kelvin is obviously the measurement of temperature, to true temperature. Who dealt with, and he's talking about more the gas fields and stuff like that. I'm not talking about that. I'm talking about the ether field, the actual background energy field.
The CMB?
0 point energy. 0 point energy.
Okay.
Yeah. So an ether field, and that's exactly it. We neglected it from relativity's being born because there was no need for it. They had a framework, a mesh framework of mathematics for it.
And that's what you do, right? You have your hypotheses. They you work them out, and you work towards things. You test. You find something that works, and so that's why, when they were testing for ether and Einstein came along, the ether tests came up empty, right? They didn't measure anything in Michelson-Morley.
No, they did. They did. It was in the error bar.
It was in the error bar, exactly. So if it's in the error bar, you don't. Now then that wasn't the last Michelson-Morley style, right?
No, I mean it's still being investigated today. There is a theory called Einstein ether theory that people are writing papers about now.
But so Michelson-Morley, for example, again in 1926, they Demonic Davros is saying Kelvin is the first one to postulate dark matter. So in 1926, they revisited Michelson-Morley and found again that they couldn't measure any ether. It confirmed the same. They said the result was perfectly definite. There was no sign of a shift depending on the orientation. That was their conclusion. And that it confirmed the original experiment that they could not measure any ether wind.
But this is all based on a spinning Earth, a spinning globe Earth. And that's the thing. Not a lot of globers get this. They say, oh yeah, the ether was deleted, it was removed. Fight the Flat Earth done a video on this, and he was completely wrong.
So and yes, I will acknowledge that in isolation, Michelson-Morley, you could say, all right, since they assumed rotating Earth, that you could then switch it and say, well, what if it's not assuming a rotating Earth? You could then say that there is ether, but it doesn't move in relation to the Earth, right? That's an alternative.
It's dynamic. It's dynamic, right? Exactly that.
Mm-hmm. No, not dynamic. Like it's not moving in relation to the Earth, right? That's a key part of if you're gonna reinterpret it.
It's its own wind over the top of a stationary Earth.
The Earth could be stationary and it's moving zero, right? The ether is moving zero, or the Earth could be moving, and the ether is moving in step with it, in lockstep with the moving Earth. Right? Either of those works fine with the alternative interpretation of Michelson-Morley.
That's it. Yeah.
Right. So, but that's in isolation, right? But as soon as you put in some of the other things that they tested, like Michelson-Gale, now it doesn't work anymore. Right? Kennedy, Thorndike, and Ives Stilwell, you put those tests in there as well, and now the ether doesn't work anymore, right? Because in Michelson-Gale, if the ether was stationary and was the result of it, then there would not have been a shift in the Michelson-Gale test.
Yeah, no, there was a shift recorded in all tests apart from, is it Miller's? And that was a corrective error. It come in at 0. And then he repeated it, and it did actually have a shift.
Well, Michelson-Morley, I put in chat. I put in.
Yeah, I'm sure all of them.
It said
I've got.
There was no sign of a shift depending on the orientation. That's what they concluded in the 1926 revisit of Michelson-Morley.
Yeah, that might be just dependent on the orientation in addition to the existing shift that's measured. Because I've got a university here with a big table of all of them listed, and it says how much was expected, how much was measured.
Okay. But in Michelson-Gale, right? So if you take the ether exists alternative answer to Michelson-Morley, the ether has to be stationary, right? Or at least within the error bars. And then you go to Michelson-Gale where they have the big rectangle. Wow. Somebody's in here putting garbage in the chat. So
oh no, that was me. That was the table.
No. Clickbait was putting a bunch of
clickbait. Yeah.
So a bunch of looks like Arabic or something.
Yeah, on the main
one. So Michelson-Gale measured a rotation, or if the Sagnac effect is measuring rotation, then they measure rotation that was matched the prediction of the latitude, right?
Yeah.
And so that adds evidence to the Earth being rotating. But
that's only on the method that there is no ether. You're then leading it down. There is no ether because it has to be a spinning Earth.
But if there is ether, then Michelson-Morley requires that it's not moving in relation to the surface of the Earth. So then, what was Michelson-Gale?
Unknown. That detected. That's what I'm confused about. Michelson-Gale did detect a fringe.
Yes, but it wasn't a Michelson-Morley type experiment. It was a Sagnac type experiment.
And this is the thing. Again, Sagnac was in full support that his equipment was measuring ether, the vortex of ether. I'll quote him.
I don't care what he thought it was. Right.
It says the observed interference effect turns out to be the optical vortex effect due to the motion of the system with respect to ether.
Yeah.
And that's 1913. That was 2 years before.
But Michelson-Gale was 1925.
Okay.
So,
but that was it, and that's the crossover period, because you've got in 1922 you've got Einstein in the University of Leiden doing relativity and ether, basically saying space without ether is unthinkable. But how the history worked is that Lorentz, after the Michelson-Morley experiment, the original one, Lorentz already had his ether theory based on electrons, and he wanted to rescue the ether from the null result. So he actually invented and came up with what would it need to be in order for the Earth to be moving and ether exist. And he come up with time dilation and length contraction from that. And then those maths were taken by Einstein to create space-time.
Sure. But so then what was Michelson-Gale measuring? If Michelson-Morley, if ether exists, Michelson-Morley confirmed that it's not moving in relation to the Earth, then what did Michelson-Gale measure?
They must have measured, again, an effect of ether.
A movement of ether?
Well, an effect of ether on the system, a movement of the object through the ether, let's say.
But the object is stationary.
The Earth is stationary.
Right? The Earth is stationary, and so
and
a rectangular interferometer is also then stationary if the Earth is stationary. And so what was it?
I thought they were spinning it. They were spinning it, weren't they?
No. The Michelson-Gale experiment was a large sitting flat on the surface, right? And they've done a lot since then.
Well, that's the same as the Michelson-Morley then, isn't it? If it's
No,
static.
Michelson-Morley was an L-shaped thing. It was one in either
Yeah.
direction, right? And
Yeah,
then they
and this is
turned
a
one
four.
where they thought that was towards the Earth rotation
Hmm.
and thought the ether wind would affect it that way. But Michelson-Gale was a big rectangle.
Yeah, it's all measuring the same ether. Put it that way. All the error bar, let's say, is the ether. That is your background noise.
Here, I'll bring up a picture of the Michelson-Gale experiment, right? And you're familiar enough with.
I know it because the silver tooth effect was born from it.
So they're
They done it on a U.S. Air Force, done it on a plane.
did what?
It's basically with the two atomic clocks. It was that experiment, and the silver tooth effect came from that. And what it actually, it's basically exactly what you're saying: a rectangle or a square, but he was moving it rather than just keeping it static.
Who was moving it?
Silvertooth is Ernest
Oh,
Silvertooth.
I
Yeah, Silvertooth effect, which was the next level from this. Then it would have been because that's what he was. No, it was inconclusive. So now I'm going to spin it and see what happens.
but
And
this
he
wasn't.
detected
But
it.
Michelson-Gale was not inconclusive. It was. It
But you've got
completely.
to understand it's conclusive to what the model facilitates.
Sure,
They're not
but
they're not going to say, "Oh, okay, this is now proven
okay.
that the Earth is stationary."
So let's. But like I said, if we accept the alternative explanation that ether exists and going with Michelson-Morley, it must be stationary. The ether is stationary in relation to the surface of the Earth. So when you go to Michelson-Gale, which was an apparatus that was stationary on the surface of the Earth, and it measured something, what was it measuring?
You got to think that you're putting a charge through the system. It's kind of like when you're measuring a circuit and you put a multimeter on there. Adding that multimeter just to take the measurement in the first place is adding as a resistance onto the circuit.
But
So it's
this
like
isn't
that. So if it was in normal free space, there would be nothing. There would be no measurement, no movement. But it's the fact that you're either sending the light a longer distance or something like that, that it's then having some sort of effect on the ether. And it's not creating a net motion, it's creating a local motion. But there is generally for a net vortex of the ether circling Earth.
but that contradicts Michelson-Morley.
Not if you have a slow dynamic one.
Okay, a very slow, because the 1926 Michelson-Morley was much more sensitive than the one from 1887.
I mean, it's just the
So
same as saying.
and since then they've done more, right? More Michelson-Morley type experiments and found the same thing, right? So if you're going to stick with ether, it's got to be stationary. So there's no vortex that's moving fast enough. Michelson-Gale measured something that was dynamic, or that was a relation that was relative to the latitude, right? And now more of them have happened since then, right? So there's let's see here, this one here in the Gingerino ring laser gyroscope in Gran Sasso, which is in Italy. I'll put that in the chat there, and I'll pull it up. That measures. It's an even more sensitive one than Michelson-Gale because it's quite recent. And they've been able to measure very accurately Earth's rotational speed and changes to it. They also are able to measure. It's so sensitive they've measured distant earthquakes.
But this is exactly what I don't get. When everybody says, "Oh, Bob confirmed the 15-degree turn of the Earth," it's a relative thing. You can think of it. You can take the frame of reference as the Earth is moving, and this is what it's measuring, or you can take the relative frame that's still, and you're measuring the medium moving.
But yet you can only say the medium's moving if you ignore Michelson-Morley.
No, because it's showing an error bar. That is the detection, the shift.
I don't think you know what an error bar is.
The error bar is the back. You've got plus or minus.
Yeah. If
one or two,
it's
let's
what
say
you can't
1 or
accurately
2%.
measure.
No, I mean that is going exactly that. You can't remove this background noise, and that is the ether. That's what I'm talking about.
No,
and
that's not. No. That's not what an error bar is in a measurement.
Right? Either way.
Hold on. If you have a tape measure that measures. Here it is. It's the one from my table, right? Here we have. I'll go big screen here.
I wish I could drop it all into your normal chat. These papers I've got here, because it's revisiting all those old experiments, exactly analyzing that.
I'll make you a comment in the chat. I'll make you a mod so you can post them. All right. So here we have focus. There we go. Yeah. What do we have?
Yeah.
16th of an inch. Yeah.
That's it. So we'll have an error bar of
a 32nd. A 32nd of an inch is your margin of error on this, right? So you can't with this tape measure anything more accurately than a 36th of an inch or 32nd of an inch, right? So that's the error bar. So any measurement that you do is going to come up with slightly off.
Yep.
Right.
And it's explained fully in if you look up null result on Wiki, it's got a perfect whole paragraph dedicated to the Michelson-Morley, and it basically says exactly that. It says it was thought to be the background error bar analysis. And now if you look at the papers that I'm going to post in chat here, that's removed it from me.
If you
I might have to refresh.
Comment quick, and then I'll make you a.
Or can I just post them to you and you post them in?
Sure.
Or bring them up even. I'll put them into the Google chat right here.
Got to find that window. There it is.
Okay, so that one. This one, and there's yeah, the second one particularly, it's a guy who's actually employed by Honda Electronics. He's in their subsonic department.
Honda?
Yeah, Honda, as in the
Honda. Okay, I wasn't sure. Because are you familiar with the conservation of consonant sounds?
No.
Hold on. So that's for everybody in Boston driving a car. There's somebody in England driving a Honda.
It's Honda, mate.
Yeah.
It's
So the R moved from Boston to England there.
That's it.
Just to. I gave Simon and Dan a little crap for that. From one, I don't know what one of his videos where he put an R in. I'm like, what did he say?
Definitely. He's from my area, literally. He speaks exactly how I hear everyone else.
All right, hold on. Let's see here. So, I'll post all quick here in chat.
Yeah, the core thing of it, what they're doing is, and this is triggered, not necessarily that Honda one. The Honda one is more they're trying to investigate any other way to exploit satellites, or how to determine satellite accuracy. And he's basically saying that either can be used, as in ether or special relativity, can be used when actually talking about the framework of space-time. They're exactly the same thing, it's just a different concept. One is a wire mesh framework with nothing inside, and the other one is the same framework but with something inside.
Okay. The problem is that we still haven't moved past that Michelson-Morley requires that the people are giving me crap. Clive Wells is saying that Honda was pronounced correctly. But
no, I mean, to put it this way, I won't get past it. You won't get past it because you're in the firm belief that there is nothing there. There is no ether there.
I'll accept ether. I can totally accept that for the conversation here. I'll put on my ether hat. Right?
But the ether hat is already on. This is the thing, because you need ether or an ethereal substance, let's say, called dark energy to fill 67%.
Let's go back. Let's not include that.
It's the same thing.
Point. But just a second. I don't think that answers it. But hold on. Ether is stationary according to Michelson-Morley, right? It's so minute that it's within the error bars of every measurement that they've done.
Put it this way, it's like saying that we're all little spheres, like ping pong balls or solid balls in buoyancy, going around vortexes of water. But that water is not actually water, it's a superfluid. It's a super helium 4, let's say. And that is your ether. We're all floating in this substance of ether. So that is static, yes.
How cold
we are the motion.
Helium 4 is cold, man. I don't feel that.
Space is cold.
I'm kidding.
But it's running through us all. That's the thing. It runs so hot through us all. It's a same thing. Neutrinos have actually been tried to be married up with the ether concept as well. That basically the neutrinos that we get from the sun are just basically the sun pushing the neutrinos that are there.
I don't think neutrinos are going to marry ether. They don't bat for that team.
You never know. Things can change. We can add an A onto that LBGT, however long it is now.
Are you spelling ether with an A? Because I like it that way.
Well, it's the same thing either way. Because the Lorentz ether theory is known as LET, so it's LET. I think that's Northern Europeans spell it as with an E, but I'm gonna do AE. AEIOU.
I like the AE that are mushed together.
Yeah, it's a good character.
So, I do love that you brought up a paper talking about satellites, of course.
Of course, and they can exist on a flat Earth, but I'm hitting my 5 o'clock in the morning.
Yeah.
Milkman's going to be coming around. I'm going to have to be robbing some milk off doorsteps and stuff.
Do you have a milkman?
Nah, do we? Hell no. No,
I don't know, dude.
No,
that's cool stuff.
Used to be back in the days when we were kids. When I was a kid, like
never had that. In America,
now we do in England. Definitely, we have these little electric vans going around with loads of milk clacking on the back at 4 o'clock, 5 o'clock in the morning.
That's crazy.
Yeah, all the kids used to chase them, nick their money. Little kids.
So all right, so ether is a little bit of a magic fairy dust. You can sprinkle it on to solve all problems.
Like dark energy.
Yes, and dark matter. Well, let's just make up a new dark something if we have another problem, I suppose.
Well, I prefer the light, luminiferous type stuff than the dark, gothic, emo type. It depends if you're into rock. You're into rock, I bet you.
I love, yeah.
You see,
heavy
all
metal is what I'm about. And,
yeah, you like the dark stuff.
Yeah,
and you do up your eyes and stuff. And whereas me, I'm Gleem. Of course, I like the light stuff.
Yeah.
I can walk in a church and I don't like it because it's a bit I can walk in a church.
You can walk. I can walk in a church.
Hey. All right. No. It's a totally stereotypical point of view that all rock people are devil worshippers.
Oh.
Yeah, it's the old religious thing. I'm anti-religious, by the way, completely against religion. Religion is a bad concept, bad idea, and that's where science comes from.
And yeah, and you again, you stand alone a little bit in the a lot of the people that I typically have on the show, they're on the other side of that.
Definitely. Well, I say the amount of space versus the amount of lights there are. I'm like one of them lights just standing alone with loads of space all around me, but it's not vast and wide space. Remember, the measurements actually say it's small and local. So
Yes.
So,
all right.
yeah, those were two more story.
All right. So I put those. What I'm going to do, I will put all the references from our talk here into on a page on my website, and I have a debates list, and I will update that. This wasn't as much of a debate, but it was. I think it was good.
Yeah, there was no lost tempers.
Yep.
I like that. Yeah, I like that.
So yeah, and Res Rhetoric is in the chat. How you doing, buddy? Oh, you know what? He needs a little. There we go.
Can you do me a favor though as well? Can you put that battle rap verse that I done in comment in the description, just for Red's Rhetoric, because I think he battle raps, doesn't he? He's a rapper.
Reds, are you a battle rapper?
I think he's a rapper. I see a rap video. I think was it Reds or Team Skeptic? I'm sure it was Reds.
I don't.
On it was Trolls versus Trolls, wasn't it? Or Tim Osmond. Osmond.
I don't know. Reds, are you a rapper? All right, here is the battle rap that Gleem started us with here. For Reds. Don't wrench me, I'm the fake one. Hold on a second. He is the fake one. Oh my goodness. Fake Reds Rhetoric. What are you doing here? Why would fake Reds Rhetoric say that he's the fake Reds Rhetoric and deny the wrench? Good on you, fake Reds Rhetoric.
There is some honesty in fake people.
That's funny. All right. But thank you. I think we can wrap it up here, and it was a good show. And if you like reggae or his rap, go find Gleem Royal Bloodline on Spotify or wherever you listen to music, and listen to it there and see what you think. Anything you want to wrap up with, Gleem?
Just to basically say thank you for a good old chat early in the morning.
Yeah.
It was good. And yeah, I need some maths to show you. Put it that way.
That would
for
be,
you to believe.
That'd be good.
Because I chat all I want, but to give you maths, I mean, one key thing that you can go straight away and get my maths is go to Sean Hawkins' channel. Everyone knows Sean Hawkins, yeah?
Yeah.
Sean Hawkins has done a hit piece on me, so just search Gleem on Sean Hawkins' channel, and it's to do with the angles of Polaris. And in the notes there, the first comment that he pins, I think, I'll give you all the data so you can recreate it in Excel. And it's all every single angle of Polaris on a flat Earth. You can select any single parallel line or latitude line, and it will give you the exact mileage to the North Pole on a flat Earth.
The mileage. All right. So, quit effing asking me to change my name, says MC Toon, still waiting for you to demonstrate your rap skills. you must have gotten here late because I did demonstrate my wrap skills. Here's my wrap. I wrapped this, and then in it is the present for Gleem. Right? You totally missed that. Rewind it. You didn't just see it now, of course. All right. Thank you. I'll look that up. But if you have that, email it to me. That'd be interesting at least. So,
Yep. Yeah, I'll drop that to you now.
All right. Awesome.
Cool. Thank you very much.
Yep.
Thanks everyone in the.
Yeah, and if you liked it, like and subscribe and click the bell and go do the same for Gleem on his music. So, all right. Thanks everybody. Bye.